We are here, folks. It's, I think, a Thursday. Does it feel like a Thursday to you, Rory?
Yeah, I think it's Thursday. It's
Huh.
hard to tell after the recent season of festivities, but yeah, I think you're right.
Will Bennett says, hello, Rory, in the chat room.
Hello, everybody. Yes,
And Rory says hello
absolutely.
right back.
Welcome, everyone.
Rory, how are you doing, buddy?
I'm doing very well indeed. I'm excited to be doing more particle things. Where else can you go to do programming, graphics, particle systems, weather, physics simulation,
Yeah.
all this stuff?
Nowhere. The internet
We're
is
unique.
the internet is a barren wasteland of memes and quizzes and
Yeah.
and one oasis of particle systems out here. So holy cow, kids, I did not think there would be so much controversy over wind. But, leave it to me to be in an argument with both Will and Rory about two different things, all about wind, and we somehow did it. We got there. So yeah, this is a little crazy. Let me show you. What do I show you? Let's see if I can bring up source tree here. I'm going to get some code in the background. Let's do this right here. Let's take a look at show you one of my recent check-ins. Where's my mouse? Which monitor are you on? Over there. Okay. Let's see what we've got here. I think I fixed wind. Right here.
Well, see, that's a good way to go into the show, right?
Yeah, it's not bad.
With your wind in control.
Yeah, so it's right here. This is the key right here. We previously had this.wind.normalize the magnitude. So we were normalizing the vector, the wind vector, to the magnitude of our calculation of the force.
Okay.
The problem is that the wind is my contention the entire time. It's just like relativity, is that wind only needs to be calculated once. Now, I'm not a physics expert. It's just only a thought experiment that drives me here, but my brain is screaming that running a calculation twice for wind won't make sense unless you've got unless you're not using the relative velocity between the two. In fact, the double calculations might work if you're working in an absolute velocity world. But my contention is that drag, the force of drag, say for example I'm moving 100 kilometers per hour through a still wind, or alternatively I'm still and the wind's blowing at 100 kilometers per hour, the force on both of those should be exactly the same.
Okay, I'll give you that.
So that's my contention. And similarly, additively, in the entire range, it should always be the same. In other words, if I've got a tailwind of 10 kilometers per hour, that force, if that's relative to me of 10 miles per hour, it should always be the same no matter what my speed is. In other words, I should always get a boost from that if it's relative to me. So I think part of the confusion is we were thinking absolute and versus relative. So making this change, instead of totally fixed all the weird problems that we were seeing where the particles were kind of accelerating depending on their velocity, was all weird. And so that's the change I made. I also notice the air mass up there. I made changes to the air mass as well because I wanted it to have a smaller impact. I wanted the air to have a smaller impact on the emitter. Will's... Will in the chat room says you cannot pass wind. I think he means get past wind is what I think he means. You cannot pass wind without controversy. You cannot. Yeah, wind is actually, I should have seen it coming, Rory. It's more, hey, Will, this is a family show. Come on. So I did change air mass as well in the same breath, and that might have made people upset and made it look like I was kind of fudging things there. But my contention is I'm allowed to change air mass and play with that because the calculations for the force of wind, one of the things it includes is this coefficient, and I think it's a drag is what they call it, but it's basically, it reflects the shape, the texture of the item. And so there's this kind of multiplier coefficient that's inside of there. Again, I am not a physics guru on this whole thing, but I have a mini physics simulator in my head that tells me the way things should be, and so it's screaming at me, and I have to listen to the voices in my head, right, Rory?
Oh, absolutely. I mean, I think that the ultimate measure of is it good is does it look good?
Yes,
Does
well,
it work on screen? Does it soothe the internals of the mind? Does it? Yeah, that looks like I imagine it should.
yeah. So it's better to look good than to feel good. Remember, my friends.
Jitsu
Remember.
7 talks now about the force of voices. I believe that's a pretty powerful force.
Yeah, that's I used to joke when I was speaking. I don't do this joke so much anymore because nobody laughed. But I used to say, I listen to the voices in my head. They say, declare a method, refactor this, burn the house down. And yeah, so, I just lost my monitor. Did I lose it? Oh no. Now what's going to happen? Okay, so I
That's an
just,
interesting effect.
yeah, so hold on a second. I need to change my resolution. Let's see if OBS can handle this. Let me know on the stream here. This is not good. I'm not going to get that monitor back, I think, while I'm running. But let's change that resolution there. Oh, it looks like that worked. OBS caught the change on the fly. Yeah, I lost my monitor over on the right. It's an old driver. I think I'm going to have to do something with that. And I've started having problems with it earlier today. And so I'm a little disappointed on that. That means my chat room is going to be to my left as I, work through all of this. Here, there's my chat room on the left.
Speaking of the chat room, it's suggested by Will Bennett that my volume is a little low and tinny.
I hear that.
Whether that's the case or not,
That's
I'm not sure.
a my end problem, I think. Let me see if I've got any way of modifying that. On my volume mixer here, I can bring you up a bit. Go ahead and say something to me now, Rory.
Hello, Mark. How are you today?
I just brought Rory's volume up. How is that, Will Bennett? Let us know.
Is that any better?
Let us know.
Can you hear me, or should I shout? Much better, apparently.
Okay,
Excellent.
so my contention again on this whole thing is that the fix is on lines 117. Let force equals relative velocity dot normalize. And let's take a look at that. We'll take a look at how that works in the with the particle emitter, and we'll play with it. And at the end of that, if people are still like, no, Mark, I have strong objections and I hate you, we'll entertain those. So right now, there's the test particle emitter shooting by. You can kind of see that there. And that's running with essentially the parameters in the code that you see on screen. One of the things I did is I did create a hue that was initialized with a target of 30 and a range going from 0 to 60. So that's going to go from red to about yellow is what that's going to do. I told it to rock, and I said the absolute variance was 30, so it can go from 0 to 60 there in that range. So that's kind of what's happening there. I think I should be able, let's check this out.
You've got an override for the absolute variance that's changing that to 25
shortly
afterwards.
You're right. I'll need to fix that. Let me just see if I do a test wind. Yeah, there we go.
It's not much difference, to be honest.
If I do that, there it is. Now, let's clear that line right there. We're going to save that out. We want to also, I want to do something else. I want to turn off gravity. I'm going to turn off gravity, make it 0. Okay? And I want to make the emitter air mass, I want to make it bigger. I want to say it's like, let's say it's like 0.3, like there. And let's refresh and see what happens. And what we should see is it kind of stop. Looks like there's a wind there taking it up. Do I have a wind? I do. Let's turn off the wind for that emitter. So I've just turned that off, and we'll refresh it. And we'll see how that comes in here. What? That did not look good. Do I have a bug? Oh no, there we go. It's working now. Okay, maybe I just refreshed too quickly. So now...
It's still going up though.
No, that's the wind on the particles. I have a wind on the particles. The emitter itself does not. And the air is thick enough that it should eventually stop its motion. That's what's,
I see.
That's what's going on there.
That's just an initial velocity if it was doing that.
Let's turn off the wind for the particles as well. Okay, so we'll turn off the winds for the particles and watch that. Okay, so we'll refresh again. Nope, not fast enough. Not too fast, I mean. Let's do it again. Here we go. Coming in. And now we should see it just eventually coming out in a radial form as it slows down. And so you can see the air, the thickness of the air, that's what this essentially I'm changing with the air mass, but basically the air mass is how big is it in the air is kind of what I'm doing here on this is what I'm doing. And so the bigger it is, the more it's going to slow down. So that's kind of what's going on there. So you see there's the particle air mass there. If I
So it's
change
almost the thickness of the air that it's attempting to get through.
yeah, it's basically it's how much does the air impact it. If I set particle air mass to 0 here in this case, and we refresh it like this, boom. There's no gravity, right? They're just going out until they die, and so they've got particles have a
So
lifespan.
there's resistance still to the emitter moving through the air,
Yes.
but not to the particles.
Technically, it's air density, not air mass, says Will. I believe you. I totally believe you. So we can fix that. You know what? Let's do that. Well, wait,
Mass
it's
per
not.
unit space,
well,
which is density.
Actually, hold on though. Air mass, air density.
For any given fixed
No.
spatial location.
No.
So-
This is, I think, right. I think it is air mass. And so what's going on here is the air mass. This is the mass of it across the. Oh wait, is that right? No. I'm probably not thinking about this. This is I was using what we had before, and the magnitude of it. I think what we saw was it was using the equation we were using. It was air mass. I'll have to look at this and we'll get a good name on this. But it's not necessarily. I don't think it's air density. Is it really air density? Maybe
Well,
it is.
it's mass per unit space.
Fine.
So it's not just mass everywhere.
I'm
it's
changing
mass
it.
in a certain quantity.
I'm changing it right now. Air density. We're going to change it to that. Because you know what? We're playing fast and loose with the physics here. And then we're going to say particle air density as well. We're going to change those as well. So we'll change both of those. So, and likewise, if I change my emitter air density to 0, essentially creating a vacuum right there, and we do a refresh on it, the emitter should just shoot off screen. Boom. Right? So there's nothing. But the mass is dependent on the density. Okay.
He's just playing with us now.
I think he is. I
I
feel like
the feeling that Will is some closet physicist who just came on here just to try
Now-
and lead us in all directions.
yeah, I feel like I'm a young kid just trying to play in the sandbox, and Will is like my older brother saying this is the right way to do it. Okay, so, and in reality, Will is likely half my age because I'm such an old guy. But okay, so that's how we can kind of play with it. So we can come in here and we can say, okay, let's set the air density for the emitter. Give it something along those lines, like there. We can also set the particle density too as well. We set these both. Let's set these both as the same numbers and see what happens here as we shoot it up. So it goes something like that before it kind of slows down, right, like that.
Yeah.
And so we can modify this by increasing the initial velocity. Notice our initial velocity is right up here. We can play with the air densities, change those out a little bit, whatever we want to do. Notice also, so let's put gravity back on here. We'll put gravity at 1 here. And let's change the air density for the emitter. Let's drop it down to 1/5 of what it is. I like that air density for the particles where it is, and let's run it and just watch it. Okay. So, and then here we're getting to a point where we're starting to slow down and curve, and then gravity's taking over. And notice the shape of the particles. It's basically dependent on, I think, the speed of that. So when we shoot out really fast, when we start up and shoot out really fast, it's kind of a narrow trail. But as we slow down our speed, right, as we're slowing that down, then it kind of spreads out a little bit more.
It's all about distance over time from previous emission point.
Let's change the particle air density. Let's increase it. Let's double it to 0.5. We'll come in here and we'll run it. And now with the essentially the thicker air,
Particles themselves slow down, even though the emitter now doesn't,
right,
which is good.
Right,
Yeah.
right, and also the it's narrower. So we'll crank this up to 1. We'll create particle air density to 1. One more time. You should see an even narrower trail behind it. Because basically it's slowing them down. That initial velocity that those particles have is slowed down so they can't get as far away from the emitter. Okay?
All good.
Let's get some wind going in here. Let's take the particle wind. Let's blow it to the right by 1 meter per second. Try one more time here. Watch the wind effect here. And so now you're seeing the particles. You can see right up behind it. They're starting to move off to the side. Let's make it a gusty wind, like 20 meters per second, and come back in here. And there's a gust. Kind of cool.
Wow, that's a pretty strong gust there.
Yeah, but it looks like things we've seen in real life, like
it's like a wind tunnel.
Yeah, like a wind tunnel effect, or whatever, right? One of our emitter's only drawing circles, right? But we could change our emitter to draw like leaves or cloud sprites, right? We could integrate our sprite class with our emitter if we chose to, if we found the need to build smoke, realistic smoke, realistic flame, I think even, not necessarily the flame that does this, but like a jet flame. I think we can do all of those things. Let's cut that wind speed in half. Let's make the wind go up as well. I think negative is the up direction. Let's see. Is it? Yeah, it looks like it's flowing up a little bit. Hard to tell because we've got the other, here, let's go in and make it a -3, and then we should see a more pronounced effect of it. So the particles, yeah, I'm hold on. I feel like I'm not seeing this. Let's turn off gravity for a second. 0, emitter air density. Let's make it 0.2. Let's try one more time. Okay. Yeah, I think part of the reason why I'm not seeing that 3, I think so as soon as we stop, yeah, there we go.
It's definitely going up.
It is going up. Okay. All right, yeah, so I'm good with that. Yeah, part of the problem was it was hard for me to see it because, the thing's moving, but it looks like that is working to me. Let's change the wind direction. Let's make it a -2, -3. Reset and see, does it behave like we're expecting it to? Yeah, I'm feeling it. So we've
that's kind of an interesting effect, isn't it?
Yeah.
Where the particles are overtaking the trajectory of the emitter.
Yeah. Yeah, well, that's the wind, basically, because we're allowing ourselves to do that because we have two different things.
Yeah.
Okay, so with that,
we have much shiny to play with.
So yeah, and with that, I'm going to say, look, wind is good enough for what we need to do. I am totally willing to go back and look at this, make it more right than it already is, but it is functional, and this is what I need. I need a particle and a particle system like what we have here, where I can apply gravity, where I can shoot things, move them around, all of that stuff, have a sense of wind as well. I need all of those things for my particle emitter. Okay, next thing I want to do is I want to change the area of the emitter. So right now we have the area, look at that, it's about to go off the screen, and it's just almost off the screen. So it's funny because it's kind of going through, it's going through that air density right there. And hold on, let me turn off my phone here so we don't hear that anymore. Yeah, but it's still kind of moving, still slowly moving. All right, and it's off screen. So, all right, so what I want to do next is I want to be able to support an emitter with a rectangular area. Is what I want to do. Right now we've got a radius. I want to change it to a rectangle. And the reason I do is because I have, let's come over here and type in the test open command, because I got these scrolls that are going to open up, and they're going to reveal player stats.
Okay.
And the player stats are going to be, it's going to be on parchment, the same color as what's unraveling here on the scroll. And so what I want is as the scroll unravels, underneath the scroll, I want the particle system to put little magical dust kind of coming up in a rectangular range that moves with the scroll.
Sure, so it's going to have vertical direction primarily because that's the way the scroll is going, yeah?
Yeah, exactly. So it's slightly ambitious, but it's going to look super cool when it's done. So the first step in getting this done is I need to get a, here, let's do this. We're going to refresh one more time here. I need to get, be able to support the emitter shape type. So let's.
So is this going to be independent rectangular emitter and circular emitter, or
No.
are we going to have one that supports both options?
Yes, that's what I'm going to do. So I'm going to come
two
in.
Two things. You didn't specify which.
I said no first to the first one.
Oh, I see.
And then I said yes to the second one. Okay, so I'm going to come in here and say emitter area type, kind, like this. Emitter area kind, and I'm going to have two options. One is going to be a circle, and the other is going to be a rect, like that. I think. And actually, you know what? Hold on. Let's look at radius, see where it's used. It's used in add particle, and that's it. It's only used in add particle. So what we really want to do instead, I think, is we want to create another class that can generate a particle inside a given area. And then that class is it sufficient to...
Well, you're talking about a point generator.
Yep.
Which can then generate points within something, and then we use those points as locations to emit.
You have inspired me, Rory. Generator. Particle generator. Like that. And then we're going to create a function inside of that. And let's see, where's radius? Do we have radius? Radius is not passed in. So what I'm going to do is I'm going to say this dot particle, let's just paste, equals new circle. Particle generator.
Mm-hmm.
Does that make sense? Oh, I'm battling between how I want the client, flexibility and client ease of client use, right?
Well, I mean, I like what you got there, because by default, sure, a particle generator, a circular one, because that's what we've been used to using. This rectangular one is kind of an exceptional one. So most of the time, you'll be having things emit from a point or a circular range, I would imagine. But you can either set the particle generator after construction to the rectangular version, or indeed pass a rectangular version in the constructor for the emitter. So you've got a few options.
Yeah, it's just a little heavier burden. It's a little heavier on the client to be able to have to create a second thing, send it. But if I default to create one, the circular one, then somebody can add another one later. So let's see, what we need here is we need a piece here that says, this should be, so I'm saying, oh wait, this is the offset. Particle position is what comes back right here. So what I need here is I want to say, okay, here's what I want. I want particle position is equal to this dot particle generator, which I should probably declare. That's of type particle generator. Okay, good. And so then I'm going to go grab this dot particle generator. Dot create particle. And so it's going to know where, and I've got to pass in this position right here, because I need that. Okay? This, I need to move to my circular. I need to move that to my circular one. We'll get there in a second. I need to declare that function. We'll do that in a second. Wait, I need this, create particle. Let's declare this. Well, I kind of like this. I'm liking this code here. What's your about, Rory? What are you thinking?
No, I'm agreeing, actually. I like the idea. So we've got a basic framework for particle generator, which says we're going to create a particle and we can tell you an origin of where we are, where that sort of should center on. And in the case of the rectangular one, well, we've got plus or minus a certain degree of x for the width and plus or minus a certain degree of y, and then we pass out a vector comprised of that. But if we happen to have our circular one in place, it will use the code you've already got, which we already know works exactly as it should, and we're kind of done, apart from the using it.
Yeah. Did I just noticed Will Bennett did a test purple burst. Did that work?
Did not see it myself, but I may have been looking at your other screen at the time.
Let's see what happens. Not working. Let's see what else I've got in here. Why is that not working? Test. Not working. You just did a drop as well.
Things not happening.
I have an idea on what might be causing that. Let me try restarting and running one more time. Oops, I may have trouble because I've got code that's not. Yeah, that's not going to like that. Can I stop? No. Oh, I almost got it. No. Don't do that. All right, we'll keep working. We'll get back and we'll try and figure out why that's not working. All right, so the get new particle position is going to create the vector. And here I'm going to say return, we're just going to return position. So by default, we're just going to do that in particle generator. Okay. Then we're going to create a circle. Is that what we called it? Circle generator?
Circle particle generator was what I believe you called it.
Yep, that's totally it. And it's going to have a radius inside, and it's going to be public. There's my public radius property, and now I'm going to then take this code and pop it in here, right, like that.
Mm-hmm.
And then we're going to just return that. Now with doing nothing else, that should everything should still be the same.
If you cut the code into where you've just placed it, does that mean that the addition of the expelled value is no longer happening at the... Oh, no, so sorry, you've got it. Well, one of them's returning... Actually, no, that's fine. That's fine, isn't it? Sorry. You've got the offset being calculated and you're doing the addition inside the generation method.
Yes.
So that's fine.
I think we're good. Okay. So this is, I'm kind of happy with this. It's more flexible, and it allows us to, create different kinds of shapes if we want to in the future. Let's see. Shouldn't circle particle generator? Yes, it should. Absolutely. Jeez.
Oops.
Thank you, Will. Yeah, we're going to keep an eye on the chat room to make sure we don't mess it up. Now, I've not done an extension where we do something like this. What is happening here? Must contain a super call. All I need is a super call. Okay, cool. Super, and I think that's it.
Yep.
Is that it? That's it. Okay, good. Nice. So there's our circle particle generator.
So everything should now continue to work exactly as before.
Except for this piece.
Oh,
well, the radius is there. Now we could turn this into a property. Let's turn it into a property. Or not. Should I? Yes, no.
Well, see, I'm wondering if it isn't more of a property of the generator rather than... Because you're only going to have a radius on the circular one.
Yeah. I know. I'm thinking the same thing. I'm thinking kill radius here. I was just thinking, well, it's a good lesson for kind of, showing how to refactor without breaking legacy code.
Yeah, true.
So I was going to do it that way, but I'm now deciding I am not going to do it. So we're going to get rid of this, and we are going to say emitter dot particle generator.
I wonder if that hasn't got to be the default value for a radius property on the circular particle generator. Because if you try to write the line there, it doesn't know that it's a circular one, and thus it doesn't know that there'll be a radius.
Wait, I'm sorry. Can you say that again, Rory? I'm going to undo this for just a second.
So the line you've got there tries to set radius, but it does it from inside the emitter. And from the emitter's perspective, you only know that you have a particle generator, not what type it is.
Yep.
So you don't know if you have the one which has a radius, because a rectangular
Yep.
particle generator won't have a radius.
Yep.
So instead, it needs to be the default value on the radius inside the circular particle generator.
The default value.
So if you just move the field from there into the circular one.
Yeah, it's in the circular one. It's right here. It's there.
Oh, I see.
But here's what I think I want to do. I think I am going to, let's pretend we got legacy code. Instead of changing our code, we're going to move our radius and turn it into, we're going to do this with it. Okay? And now we've got a setter side effect. And when that setter comes in with a new value, we can do this. We can say if this dot particle generator is not, I'm sorry, hold on, instance of circle particle generator. And I think what I really want to do is say if it's not that, if it's not a circle particle generator, then guess what I'm going to do? I'm going to make it one. In other words, if you set radius,
okay.
If you mess with that, I'm going to say it's that. And I'm going to pass in, here, let's put this at the top.
New value. Or, yeah.
I'm going to use radius right here. Okay.
Like that.
So we're going to do that.
You say that's particularly useful if you happen to be writing code, but you don't necessarily control the calling code. So here we are making something in JavaScript, which could very well have been embedded in any number of applications. And this particular property was, or the field was public and was accessible. And so we don't necessarily know who's calling it. So to keep its existence there can very much be a useful thing to do.
I'm going to swap these around. I was not anticipating having a balanced if-else block. Just to simplify at the top. So if we are an instance of the circle particle generator, then boom, we're going to just assign the radius directly. Otherwise, we're going to create a new one. So there's set radius. We could also create a function that similarly sets its height and width and for the other one. But let's test this. Let's see if this works. Let's do...
You appear to have an error in the bottom right of your visible screen. Line 97, offset is not liked.
Oh, shoot. Yes, because I was... Oh, the initial velocity was also a piece that was coming back from this. So we need this to either return a tuple that's two different vectors, I think, or we need to kind of create a new class to hold the two vectors, I suppose. Or we need to create a second method that gets that offset back. Yes, that's the initial velocity also needs to come back. I am leaning towards a class that has both of these in it. So I'm going to say class, and we're going to say position plus velocity, like that. Yep. And it's going to take in two parameters of type vector, I think, like that. And this is going to be public. And I think I can make it read-only like this. And this is going to be velocity, like that. And now I'm going to change get particle position to do this. And we'll fix that in a second. Get particle position is this. And so now we're going to say return new position plus velocity of that, comma, and my velocity is, whoops, let's put a marker here, go down and find it, is initial velocity right here. Whoops, let's put this up here. And oops, I need velocity passed into as well. We're going to have to do that It's getting a little more complex, but ultimately I think we're going to be happy with it. So let's grab, did I miss something here?
You've also got some particle velocity degrade, which is a potential field on the emitter.
Yes, it is, and I'm thinking that's going to be, I'm going to move that over here. Thanks for that. We're going to add one more option here, which is the particle velocity degrade right there, which this is basically, instead of, so if I'm moving like this, and that part, you know what, the particle velocity degrade I added so that things would slow down, but now that we have air, I think we actually don't need it. I think I'm going to kill it.
The additional force will naturally do that.
Yeah, I added that because I was thinking, well, do I want it to be a true conversion of the velocity? And I wasn't liking because the particles were just, staying with the emitter. But now we have the ability to fix that. So, all right, so let's see here. So velocity dot add. This particle initial velocity get value. So hold on a second, like this.
What's the difference between velocity and particle initial velocity? So velocity is is actually the velocity of the emitter.
Yep. So
so that's the one that needs to be coming in there.
I'm going to say emitter velocity, which is a vector, but then I'm also going to pass in this particle initial velocity. Which is a target value. Remember, we talked about that in the last show, which is just this awesome thing. All right, so let's go in here. Let's grab, take emitter velocity, and that takes this piece, and then this becomes particle initial velocity get value. Those should clean up.
That's
nice. Return, new. That's what I was missing down here. New position plus velocity, and I think, is that it? New.
You can have a new position.
Wait.
You have.
That's what I wanted, right? I think. Yeah, I think we're good.
Does add
now.
return the value? I guess it does.
Now, what is wrong here? Why does this is not a symbol? Oh, yeah. Okay, we'll fix that now, because we need to do this. And so here we're going to say return new position plus velocity. And we're going to put this position, and I guess we're just going to,
Do we have to have an implementation for particle generator itself? Because it's got no specific size or dimensions to it. Can it not be abstract and us just omit some of that?
Yeah,
I'm not sure how this works.
Yeah, it's a good idea. I like that as well. Will Bennett's saying you could also do a tuple, like vector. Yeah, I don't know, I'm still kind of liking the typeness of this, but only by a little bit.
You can have many different reasons to have a pair of vectors. This one names the purpose.
Yeah, it gives me a little bit of a benefit. That's all so I'm going to kind of keep it. So let's see here, emitter velocity, I think multiply offset. And this is the emitter velocity add offset, position add offset. So the position is essentially representing the center of this. Okay, so now position plus velocity is returned from get particle position.
Is position not the original position of the emitter, rather than the position of the particle, which will also be being picked up? Actually, yes. How is that compiling? It's not a world object at this stage, is it? Where's position coming from?
I'm sorry. You know what? I'm deeply thinking about JavaScript syntax right now. I think all I have to do is just put abstract here, and I think it'll work. Is that right? Make that abstract.
Scanning things now.
Let's see what happens. You seem to pick up the abstract keyword. It doesn't like it.
Yes, you can stick the word abstract in front of the method name, and you don't need to give it a body of any kind, as long as you also state that the class is abstract.
Perfect. I just did that. Okay, good. So we've solved that little syntax problem there. Okay, so now get new particle position. It's going to return a position plus velocity. So we are going to now change this particle. We're going to call this particle start, like that. It's going to be this. And then we're going to say particle start dot position, and then particle start dot velocity. And I think that should get rid of all of our squiggly underlines. No, not this one. What is the problem here? Expected 3 arguments.
Arguments.
Okay, that makes sense. Okay, emitter velocity, so that's going to be this dot velocity, and this dot particle initial velocity. Okay, good. That should get rid of all our red underlines. Okay, so now at this point, Rory, we should be able to, I think, simply refresh the screen. Let's actually compile and run, because we want to get Mr. AnnouncerBot working there, so Will can, call our attention to his suggestions, and other people in the chat room can do that too. I just realized I'm gonna probably have to kill Chrome, because I bet it's not going to load. Yeah, it's taking too long to load. Yeah, there it is. There's our error. So that means kill Chrome. Let's go ahead and do that. Chrome has been destroyed. And my chat window's back up. And let's stop debugging. Try one more time. And what I'm hoping to see when this loads, okay, I'm not seeing it on the stream. Is it because I haven't refreshed the stream, I think. Let's refresh the stream. There it is. So it's the same thing we saw last time, right there. And Roy Becker has planted the seed, grown some flowers over there.
Everything's working again.
Everything's working.
And, we didn't break anything. As you say, the firework, the series of particles is on screen. It's doing what it did before. But now we have moved some of the functionality out into a circle particle generator. And that allows us to now make additional generators and switch them out to give different effects, exactly as intended.
Now, why isn't purple burst working? Do I have the wrong command on that? I want to find out what's going on with the commands. Purple burst, purple burst. What's failing here? Try again. Test, purple. Oh, you just did it? We have not hit a breakpoint. Why no breakpoint? Mr. AnnouncerBot is running. Let's do a test of.
Hey, Mark.
Yeah,
That works.
We both did it at the same time. I saw you. So why isn't a test working? Why is that failing? So are we even getting here in test? That doesn't make sense. We haven't made any changes at all here. Test, just anything. Oh, here we are. We're in here now. Why weren't we here before?
Okay, what's the command we have?
Okay, hold on. Let's see what's going on. All right, test command coming in is purple burst. So let's step through it. What is going on? Purple magic, purple burst. Well, now, okay, let's run it. But yet I don't see the purple burst.
Okay. Is purple burst configuring things, and we have somehow broken the specifics of its
I
configuration?
think we've broken something, is what I feel, but I'm not entirely sure what.
Some screen centers.
Rory, can you
sensible.
give me another test purple burst? And I want to
Yeah.
come in here and see what's going on. Okay. All right, let's do this. Let's change our start to just show only the purple burst and see what's happening. Maybe this is where I'll get my comeuppance. Okay, so we're going to do that. We're going to say run. We're running. And let's refresh here and see if we can see a purple burst here when we refresh. No purple burst. Is it because of our changes to wind, I wonder?
Are we blowing clean off the screen before it happened? That seems a little unlikely.
I don't
Mind you, we
know.
have no wind. We have no specification of wind, at least.
Yeah, let's,
So if we have no wind, are we adding an undefined somewhere?
I don't know.
Because the wind is undefined in this circumstance.
I do not know. Let's set a breakpoint here and refresh and just step through it all the way, make sure there's no problems. I should have checked the console log as well. That's definitely running through all the way. So, okay, let's just as a
where's
quick
the piece of
test.
code where you add the forces together?
Let's do this just as a test. Let's grab these last lines here,
Okay.
and put them in purple burst and see if adding those just as real quickly, just test our theory, is going to fix this. No, does not appear to fix it. It's still loading, but no. What is wrong about purple burst? Is it, let's see what other ones are not working here. Let's try, let's try blue ball. Refresh. Not working.
All right. Was that purple magic there? Because that worked.
I'm gonna try that. All of these were working.
I
Oh,
did
there we
see
go.
something go across the stream there, see?
There we go.
So there's something distinct between purple burst and purple magic that causes one to fail but the other not.
This goes in the screen center.
There's no gravity, but is there a location that just... Oh no, screen center, so it should be fine.
Yeah.
No velocity.
I'm like totally blown away and stunned because there's nothing in my recollection of what we have changed that should cause one to work and one to fail. Okay, so hold on. Let's keep testing these and see what everything that works here. So, so we know that purple magic does work, right? There it is right there. We see that and it looks great. Okay. And, oh, reminding me though, there is a property, I think an emitter. Degrade is what we called it. Had the word degrade in it, I think.
That's true.
I want to get rid of that and clean that up. Degrade. Velocity degrade factor. Oh, it's here. No, wait. No, that's add meteor. That's not what we wanted. We want something else.
I think there was a second entry in there when you were looking for degrade.
An emitter.
Particle velocity degrade.
That's what I want
There
to
we
do.
go.
So let's see, not using it anywhere. Okay, so tab next reference. So I'm just cleaning that up. Let's look at the, let's go get one that's failing and see if there's anything in the, we should have done this to begin with. See if anything in the console window. So come back over here. Blue ball is failing. It's one of my favorites. Let's go refresh, inspect. Give me something. No, nothing.
Okay. So it's succeeding in a way which is entirely invisible.
Maybe.
Which is something of
Yeah.
a contradiction in ways, but...
Maybe. Let's see what smoke, if smoke is working or not. Nope, smoke is not working. Build test particle. Yeah, it's working. I'm like kind of stunned about this.
So magic and test particles are fine. Everything else is
Yeah.
total.
All right, so let's do this. Let's take purple burst code and copy it and put it inside the build test particle code. and see what the heck is going on here. So, and we'll just kind of look at and compare the two all the way down.
So we have an emitter which takes location but does not take a velocity in the second case. That's something, I guess. It has no initial vector velocity.
Right.
That's interesting. How many of these things are attempting to move?
Yeah, this one's not moving. Smoke is not moving. The other one's not moving too. That could be the clue. Let's try this actually. Let's go into smoke. Let's go into like say build smoke.
Something that's not working and cause it to move.
Yeah, let's see if that's going to be the deal here. And we're going to say new vector 1, 1 like that. So there's build smoke. Refresh. Oh, I didn't tell it to use smoke. Let's start with smoke. Yeah.
There we go. Wow. Got to move fast or you get killed.
Yeah, that's crazy. Okay, so we've got a problem somewhere with regards to our velocity. So I think we've somehow have managed to...
I think we must be making assumptions that there is a velocity, and then when we add our new velocity to that velocity.
Yeah, I'm wondering if the problem is this code should be exactly the same. Oh, I did change the particle degrade thing. I did do that. Let's see what else. I think the problem is here. Get new particle position. That's my sense.
What happens if we take something that is undefined? I mean, is there a default value for the emitter's velocity when it's instantiated at all, even if it is just a 0, 0 vector?
Let's do this. Let's set that here. Okay, wait. Let's.
That has a value.
Yeah, it does, but that's because we gave it at the beginning. Let's restart our game, and then set a breakpoint there. So in build smoke, we're going to come over here. We're going to kill this, and I want to see what's coming in, and check the math there. That's my theory in terms of what's going on. So there's the refresh. It's done. Now set a breakpoint over here. And emitter velocity. Ah, look at that. Not a number.
Yep, not a number.
That's going to mess with us. Why isn't that initializing? I don't understand that. I thought let's go check the emitter constructor, which is right down here. That seems like it should be
yeah.
working.
Huh.
That doesn't make sense to me. Somehow it's turning into not a number.
Let's have our breakpoint on there and see what it is. Oh, hang on.
Let's check the calling code on this. The calling code on this right here. This dot position, this dot velocity. Yeah, this dot velocity is undefined. Add particle. Yeah.
Okay.
Oh, wait. Oh, it's in a for loop, so it still should be this.
None of that's changed recently, though, surely.
Yeah, no, that's all good. But somehow velocity is undefined.
Which is different to a vector of not a number, not a number.
Well...
Which we observed elsewhere.
Yeah, that could be after the math, though.
Okay.
I think is right here. So this right here. I think it's because it's typecasting it to a vector that it's getting all this, because does that feel true or no?
That's possible.
All right, let's do this. We could do this. We could do a check to see if there's a problem with the emitter velocity, and if there is, fix it here. We could do that. I would love to know a little bit more about why this velocity is suddenly not so good.
I'm curious to know what its value is immediately after it comes into the emitter's constructor, because it's supposed to be vector 0.
You mean right here?
Modified. Well, so we check its value on line 59 and then check again on line 60 to see if the super has anything to do with it.
All right.
Or alternatively, maybe change. That's the thing you could do. Change it to a property and then check in the setter whether it ever reaches undefined, or if something's trying to set it to undefined, or indeed to something with not a number.
Yeah, so here it's going correctly. Up, out in there, and we're just in the constructor of it, and we've just initialized the velocity. Yeah, it's being set somewhere. Probably this dot prior
To be
velocity
fair, we haven't
add.
changed anything about world object, have we? So it should be
Yeah.
consistently good there.
Yeah, it should be, but something is definitely not working with that. I wonder if it's a change. Have I tried any of the, do you remember, Rory, if I tried any of the other non-moving pieces since the start of the stream? I'm wondering if something else changed
Oh, right. I see.
since yesterday's show.
I do not believe we have. That is a fair point. We talked about them.
All right, let's go to, we are running right now. Let's put a breakpoint here. There we coming in, and just confirm. Yep, this velocity is not a number. It could also have something to do with, where should I fix this is the question. Add particles is in update. The super update. So we saw this before. Remember I did this thing where I was like, let's call super update because remember we saw that the same thing, that the velocity was not calculated yet. And so we did
so
that.
in our previous episode, that line you're highlighting now was outside the if immediately prior to it. So it happened regardless.
Yeah.
At the moment, that's only firing if there happens to be wind.
Yeah. So now,
actually, yeah, that's not going to fire at all. There's no other copy of add
so,
or apply force.
So now I'm thinking
Update,
I modify it like this right here. Will Bennett is probably just getting so squeamish right now from these changes because I'm taking his beautiful engine and tainting it with, by creating world objects that hold their own custom forces. So yeah, Will, by the way, Will has a pull request out there to improve this. And Will, I was going to bring it in on the show today, but had some combinations where some pieces I didn't want. And so I was like, I don't think I want to go through and cherry pick right now for today's show, but we'll probably look at it again next week. But my theory is that this is going to fix it, that change will fix it. Let's go ahead and run and we'll refresh and we'll see what happens here. Check the world update, says Will Bennett. So I feel like he was kind of already told us. No, it didn't fix it. Oh. Hold on. Let's see what's happening here. Add particle. Why aren't we stopping here? Nothing in the console window, I trust. Why? Oh, here we go. Now do we have a valid value on velocity? No, we don't. How did we get here? Add particle is only called from add particles. Add particles is only called from update. Update's got the super update. Did I fail to hit refresh? No, I'm pretty sure I hit refresh. Yeah. Wait, let's do this. Let's do this empty cache thing and hard reload. Nope. No difference. Let's call super update. Let's put a watch out on this dot velocity. Let's turn off my caps lock. Okay, let's call super update. Is it going to modify that or not? What's my watch looking like? It did not modify. What does it need to modify that? Update acceleration, update velocity.
So is it possible we've just captured the wrong this at some point? We've entered ourselves into a loop or something like that. Do we know that this is, because this is what Will Bennett's suggesting, is to see what the this is inside the update?
Yeah, we can. I don't think that's the problem, but let's see what happens. I mean, I've got a watch right here on this dot velocity. Hold on a second here.
It is an emitter.
Update velocity. Let's go drill. I'm actually drilling into this right here. This x is 0. Factor is 0.01. That's the multiply should work. Fine. And now we've got x zeros and y's also 0. So the length should be 0. Update velocity and prior velocity add acceleration. Prior velocity is not a number. Prior velocity. Where is that set? Reset parameters.
That's called from the constructor, as I recall. It's the last thing that happens in it.
It's
so it should
set
be doing
in
that.
reset params. We pass it over to this velocity.
Velocity, which you've already set to.
So at some point, velocity gets to not a number, and then it stays, and this calculation just continues for some reason. The question is, how does that get to not a number? I'm not understanding this at all. Giving it the smallest movement makes it work. And movement of 0 fails.
I guess it's because it's an initial value, isn't it?
Yeah, but it doesn't make sense to me. It does not make sense. I'm just going to run it so we don't get that lockup problem that sometimes we get. Yeah, I think I think this is going to take a little more debugging than I want to spend time on right now. Slateboard says this conversation is beyond my comprehension, but I like code, so I'm still here. Thanks, Slateboard. We're glad you're here. Break in the constructor and then check reset parameters, suggests Will. The constructor for right here, I think you're talking about the world object constructor and check reset parameters is what I think we're talking about. Here is he's suggesting the breakpoint. Oh wait, this is hold on. Where's the call stack?
From polar 0, 0.
How is that failing? What is going on there? It's for the individual particle we appear to be. I'm running and now why am I not at a...
So what if you stick a watch on vector.from polar 0, 0? What does that produce?
I guess I can set a breakpoint there on that piece right there. So it's...
No, but you could evaluate it directly because it doesn't depend on anything external. Just
okay, hold on. Particle position. Oh wait, this is just the part of the problem we've already... Sorry, I was just deeper in to the problem, I think, here. Yeah, let's break in emitter. I think you're right. Let's do that. We'll set the breakpoint there. Let's run. And let's refresh. Okay. So let's go in here, reset params, set a breakpoint, run. So here we go. Applied force, acceleration, and then here, this is good, and velocity is good. So that's all good. The first time we're in here. Now we're coming in for another world object. This could be yeah. So let's do this. If velocity dot x equals NaN, I think, then let's say debugger. Let's see if that gets us anywhere interesting. No.
That seems awfully strange. Having said that, that only applies at the outset when you're creating your world object. So if it happens at any point after that, you're not going to hit that value.
Hold on one second. I want to come back in and I want to try that one more time. I'm going to kill all instances.
Well, then it says there's an alternative way of doing that. It says is nan brackets velocity.x. Maybe there's a distinction in the way that's detected.
Maybe. Okay. And let's do this. Can set a breakpoint on the last line. I can do this in C#. Does not look like it. All right, so we'll just do a console log.
None.
Man, like that. All right, so we're going to do that. We'll send a message out to the console. I need to kill every instance of Chrome, which I've done. Let's try starting it up, running it again. Set a breakpoint here on line 54. I feel like I want to build like a slide that kind of comes right here and just drops a little piece. If I push a button and a hot piece of pizza drops on it and just slowly, just conveyor belt brings it and I can just, chew it and hit a button and move it off to the side, so people can see my face. Another, robot will wipe my mouth, and then comes back and feeds me, nonstop. I don't know. That's just maybe me. Why?
It's all about the code.
Okay,
Why
here we
waste
go.
brain cells on anything
All
else?
right.
We've got a result. Okay, good.
Thanks, Will.
So
where
did that come from?
Where are we? Pre-update. This reset params. Pre-update. I just want to kind of back out of this whole thing. We're going through all the characters in the world. We should only have one, I think, character in the world. Why am I not getting any help, any assistance on this? Add watch. Not available. That's why. Interesting. And so there's a kind of a limit to how much I'm going to be able to get out of this here. So we're definitely getting, we've reached that point on the world object. Can I do this on it? Let's see if I can do this. Let's see what we've got. It's the emitter. Okay. So
it's the right object.
Yeah.
But we've reached reset params in a way other than going directly through the constructor. So we did the first iteration, constructor, reset params, everything was fine. Some other stuff happens, and then we hit reset params again, and by this stage we've got a funky value.
I have another theory on this. Let's do this. Let's run this and let it keep going. Just a quick kind of check. I want to take my wind code as this code, and I want to comment it out and see what happens. So I'm going to comment that out there. And also in my particle, I'm going to comment out its wind code as well. There it is. And save that and refresh. Whoops, am I at a breakpoint? No. Why is this taking so long to load? I think I might have to kill all instances of Chrome again. Let me stop. Reload. Yeah, it's not feeling very nice. All right, let's shut it down. Kill all instances of Chrome. Start one more time. Whoops, hold on, debug, stop debugging. Okay, start one more time. Yeah, I think that pizza conveyor belt idea is brilliant.
That's not a bad plan. I do with one of those. You make that, you ship me one, right? There's some smoke.
Wind. Something in wind is killing it when velocity is 0. Let's see what's going on here.
Null wind is bad.
I almost bet it's not here.
All right, binary chop. Pop it back in, and let's
Refresh.
prove that that bit of code is fine.
I feel like that's sufficient proof that that's fine. I just came in and did a refresh on that. I don't think it's there. I think it's here.
Well, that certainly narrows it down. That's good.
Let's see what's going on here. Let's undo this. If this is not wind,
So Will Bennett says he thinks he's found a bug in world. Applying forces is using this instead of world.
okay, maybe, but it's, you know, make sure he may be slightly behind. There may be lag, and he may be slightly behind us in a few seconds.
Possibly.
World update. Okay, if you want me to go there, I can make that change. It's in world.update. World is equal to this. And is there this call in here? This.
There you go.
There.
Line 62.
Okay, we can do that. Let me respect Will's indentation for now in here, so we'll keep that the same. I don't necessarily think that's but what the heck, we're gonna do binary chopping. So let's refresh, we should see it's still working. And why is it taking so long? Not at a breakpoint. Yeah, it's something is really not right here. At this point, I'm right-clicking, and I don't even see the right-click menu, which usually indicates an infinite recursion kind of problem, where we're just, you know, stop loading the page. Let's get out of there. Kill every instance of Chrome again. I'm not sure what we've got like a couple problems we're chasing at once here, it seems. Let's debug, stop debugging. Okay, it looks like that's done. Let's run one more time. So we've made that change there. No need to restore.
Come on, show us a smoke.
Doesn't feel good. Debug, break all. Where are we? Console read line. What? Okay, there. Yeah, but that world change got us here? That couldn't have done that. I don't believe that.
Does seem a little strange.
Let's go back over here, see if it was this one, because I don't feel like we have actually tested this out. Let's just come back, refresh one more time. No. Okay, this is just looking ridiculous. I'm like shutting down Chrome so many. There are bug reports that they must be getting from me. They must be like, oh my God, Chrome is like crashing, billions of times on Mark's machine. We've got to work harder. Okay, I want to go back to world. I want to look at that very closely, make sure there's just no way. That doesn't make sense.
All right, well, the last thing we changed is that was this. So if you put it back to, what is it, allegedly the wrong code, and then suddenly Chrome starts working again, then we have some interesting issues.
Yeah, well, this in this case is the character, I believe, is what it is. The character forces. So let's look at that.
Well, maybe we need a const character equals this.
No. Not any happier. Let's see if we get any luckier with the break all. We get in the, nope, just getting us over there. Just hoping we can do that. What has happened? Yeah, I'm sorry. And it says we're paused in Visual Studio, but we're clearly not paused in Visual Studio. All right, I'm going to kill it.
I
Kill
have a
it.
feeling somebody's messing with the implementation of reality.
Kill it. Yeah, it feels a little bit that way. That's what, you get. This is like in, the movies all the time, right? That's what you get when you try to do science, right? Science causes problems. Okay, so we've changed the code back there. We had, what is this? Oh, this is an emitter. Hold on. Let's do this here. I didn't realize that I'd left that at that point. So we've got emitter there. We have particle copied. So this should work. This is the code we've seen work before. And I command you to work. There we go.
And there it works. Well, see, that's what happened, right? You just weren't authoritative enough
That's
before.
you're right. I was feeling a little weak. Okay, so something going on here. All right, let's go back to world. Let's take this one step at a time. Let's change this to world.
Sure.
Save. Okay, come
Right,
over
time to
here.
save, switch across,
Refresh.
refresh.
And it
Still
works.
working. Okay.
Good. Now, next, let's one at a time. Particle. Taking this off. Boom. Save. Refresh. Still works.
Hang on a second. Everything just started working for no good reason.
Yeah, I want, make sure your airbags are, you're buckled up and your airbags are on, kids, because I'm about to uncomment this code right here. Save and refresh. 2 problems.
Okay.
Okay. I think it was a cache issue, by the way, before.
Mm-hmm.
We've got a problem here that we didn't have before. Well, I did bring super update here, and I'm applying it here, but before, the other time I had it here.
There was a version of Super Update where it was immediately prior to the if this wind conditional.
Yeah, before I had this.
Well, yesterday there was one.
This is what I had. I had this moments ago. Let's go back and refresh this. Let's stop. Empty cache and hard reload. No, by now I should expect it to be drying. It is not.
I feel like I remember a version where the update was post-wind operation, but still inside the conditional, and was immediately prior to the conditional as well. So each of your lines, the 2 updates, would move up 1 actual position.
Hold on, I want to go back over to here, and empty cache and hard reload. Nope, nope, nope. Still not working. We have really gone backwards in time. This is like what is happening? Empty cache, hard reload. Nothing is going on. See, now we've essentially restored the code to what we had moments ago, and it's not loading. Are we in agreement that that's essentially what we believe is happening?
I wonder if line 149 wasn't right up at the top of the method instead.
Oh yeah. We'll just undo it. We'll take it right up to the top. But there we go.
So that code there is what was working before.
All right, so that, and then over here in world, we had this as world. Right there. World forces for each, for supply force to character.
I think we had a this and a world, both of which seem to work. But yeah, other than that.
Yeah. All right, so we'll do this for a second. I'm going to bring this in 1 line at a time and see what happens, because I am, nothing is clear to me at all about why this is failing. And it's like in this kind of loop is what it seems like. Okay, good.
There's smoke at least.
Smoke.
Back to some level of normality.
Yeah, some level. All right, here's what we're going to do. We're going to do this and this. And we're going to also do this. Whoops, not that I wanted. We're just going to send a 1 out to the console.
Okay.
We're going to refresh. This is going to verify that we're actually reloading up. And so we see the number 1. Yep.
Lots of. Good.
Lots of 1s. Okay. Let's change it to 2. And we're going to do this. Come in and refresh. 2s. All right. Nothing controversial there. Changing it to a 3.
Debugging techniques from the 80s.
You're welcome. What do you want to bet? I can uncomment all of these lines and it will suddenly
Oh,
magically
man.
work. Here we go. Magnitude.
I would not bet against it at this stage.
Ooh, is it air density?
No, we wouldn't get to blame Will, surely.
Is air density? No, it's initialized. Air density is initialized. We can't blame Will. How's Will even responsible
Well, he was
for
the one who
this?
told you to make it density. I was going to say it's a naming
just the
issue.
name of it. Okay. Yeah, maybe. All right, so we're there. Good. Now we're going to go to force. I bet it. Yeah, it's going to likely to be in one of these last two calls out here. Okay, 4. I meant to change that to 5, but I think we're good. Here comes 5, and let's call super apply force. 5 is good.
So we're just updating too much, basically.
Let's call super update.
Nans.
He doesn't like the second call to super update. That's
So
my problem.
that's weird.
All right.
I am blameless, says Will.
Let's stop and rewrite. Refresh it. I mean, hold on a second. See if we can refresh. Empty cache, hard reload. I don't think we can get out. I don't think we can get out. This is the weird thing, right? It's like, I think it somehow, so for Chrome to behave in this manner, Rory, where it's I right click, I just right clicked it, no menu, no menu, no menu. I think it's in a crazy,
been a very tight loop.
I think it's a recursive loop, not a tight loop. I've seen it in tight loops, no problem. You just right click it and it pops up.
So it's just adding to the call stack again. And
Yeah,
again,
yeah.
and again.
Notice
And
it's froze. It's frozen on the right. It stopped. Oh no, they're just added another one, but it's now really slowing down. So I think somehow this call to super.update is coming back down to the emitter, I think is my theory, but I can't quite figure out how that could happen, but that could explain what's going on inside here. But I am like, I got no real options here but to close this down and restart it. So let's come in and do that. It's that second call to super update. We needed that second call to super to update because the apply force I thought was not changing things. If I
here's a question though. If you need the update in order to have the apply force physically function, okay, if that's true, then how is the gravity working? Because just above there is no follow-up update.
Gravity.
Line 146 is an apply force that pertains to gravity and is not followed by an update.
Huh. Yeah, you're right. Maybe I don't need it. Let's just see if I don't need it. Wouldn't that be awesome? Because we added it yesterday thinking that we needed it. I have tons of instances of PowerShell open because I've been killing Chrome like crazy. Let's try one more time. We're going to run with this and see if now the wind works.
Will Bennett is saying that super.update should be the last statement in emitter update, but it should only be called once.
The last. But I think I had to do it first because I was getting... All right, so there's that. Let's try Will's suggestion. Let's move it to the end of super update.
Just to give you a heads up, mate, I've got about 5 minutes and then I have to hard leave pretty quick.
Hey, you know what I want to do, Rory? I want to create a Mr. Announcer bot scene that's like, Rory's got to go. And so you just type in Command RG and it'll, do that for you. So now
I've make me look really lazy.
Now I've got super update over here at the end. Let's do a refresh and see how we do.
Is that the only instance? Did you remove it from the first, from the top of the method?
I did. It's gone. It does not like it at the end. It is not happy about that. I am super mystified. I'm gonna put it over back at the front again, and I bet we've got to kill. I'm gonna put it back at the front, and I'm just gonna go with this now, and I'm gonna see if wind works now that we don't have the call to update over here.
Okay.
So that's
so Will's saying that by putting it as the first statement, we're effectively a frame behind in our calculations. Technically, sure, but actually, if it's only one frame behind, that still looks good on screen. If it actually does still physically imply.
I feel like I'm in a meeting room with you, Rory, and we're like, should we ship or not? And you're like, technically, it's not bad. Rory can make anything seem not bad. All right, so I'm going to do this. I'm going to do this. We've
It's a
got,
zombie apocalypse, but it's okay.
yeah, technically we're exposing ourselves to more viruses. And so we're making ourselves stronger. So now when we run, hold on, we're running, here it comes. Now I want to type in test purple burst and see if that works. Nice.
Oh, wow.
And now I want to type in, but now we got to go test orbit. Oh, but that's not moving either. We need something. Oh, no, wait. That is moving. Orbit's not working, I think. That's because, yeah, we needed that second call to get that orbit to work. I bet. Yeah, the problem is I'm applying forces outside of the range of when I'm supposed to be applying the forces. Roy, let's give away copy CodeRushed.
Fair enough.
Take a break from this for a second, and
Yeah.
it's time to do another
Code Rush giveaway.
We're going to do that. We give away copy CodeRushed every day on the show to one of our followers, and we've done like about 70 shows. We got about 383 followers, so your chances of winning are about 1 in 4. Not bad if you're a follower of the show. CodeRushed is an add-in for Visual Studio. It includes templates and refactorings and other features. I'm using it right now in TypeScript, but it also
It's
has
there
support.
to speed you up at the things you do every day, so you can spend more of your brain solving problems and not getting in your own way and mistyping or
That's right.
all sorts of useful things in it.
That's right. Rory's a customer as well as being an employee of DevExpress. Anyway,
Wouldn't be without it.
Today's lucky winner, watch for it. It is
Ambigera.
Ambigera.
Congratulations.
Congratulations. I will send you a DM on Twitch with instructions on how you can download a copy of CodeRushed. Rory, I'll say goodbye to you.
Thank you very much, my friend.
I'm going to, I think, continue to try to flounder a little bit on this.
I figured you may. We'll catch you on Tuesday, is it?
Next Tuesday. We will see you next Tuesday. Thanks so much, Rory. I really appreciate you being here.
No problem, my friend. See you soon.
All right, bye. Okay, thanks to Rory. So I am, I think I'm going to, I said I think I'm going to flounder. I don't have strong ideas yet on how to get in here to see the problem. What I don't get and understand is what fundamental change could lead to this behavior that Chrome is essentially becoming, non-responsive. The only time I've seen that happen before is when I had a recursive call, Will says, need to find out why the super.update call doesn't work at the end. And when I put it only at the end, I'm forgetting this. I'm totally forgetting what happened when it was only at the end. And so I'm going to try this one more time and see what happens. Probably step through that. Yeah, I think so too. Well, I want to just try this and see where we get with it just at the end like this. So I'm going to refresh, empty cache, hard reload, and I think am I stuck here with it at the end? Yeah, there's my inspect. Is it still responsive? Yeah, we got not in numbers is what we're coming in with there at. Can I set a breakpoint? Not hit, no symbols loaded. Because I moved it and changed it around. Let's kill it. Let's try again. Kill Chrome. All instances of Chrome have been shot. By the way, every time I kill Chrome, it destroys my chat room. I bring it right back up. But if you happen to put anything important in there that I'm not seeing right around the time I said I'm killing Chrome, I may have missed it. So let's see here. There's my super update call right there at the very end. And should I set a breakpoint here or not? Let's set a breakpoint once and see if it destroys it immediately and see what happens. So we're going to run. Here we go, we're at the breakpoint, and we are going to jump into it. Update acceleration. What do we have here? Inverse mass is 1. Applied force is okay. Wait. Did I already get it? This dot x is not a number. So my x and y's are not numbers when I'm coming in to, hold on. Is that because, let's do this. Let's bring up the call stack a second, see if I can go back. No, the first thing I do is update acceleration. Let's double check that. This dot x is undefined. Oh wait, it's not x though. We were somewhere else. It was this dot position. That has got, so what's my this then? Let's go back. Let's go back to where we were. Oh, it was the applied force? Is that what it was? Let's see. Is that right? Is that not a property? I've got no IntelliSense here. So let's just type that in and see if we get it. Yeah. Okay, so the applied force is not a number. That could be from what I'm doing here, though. Let me comment this out for a second, and let's see if that kind of solves my problem. I'm wondering if, okay, it's loaded the CodeRushed rocket logo. What's happening here? Why is it taking so long to load? And it's not responsive. I think it's because my change isn't getting updated here. Just killed the chat window. All right, chat window's back. All right. I'm wondering if I've got a problem somewhere in here. And I'm applying the force, and so then the force is applied, and then we try to apply it, and we're applying a not a number force to it. Is what I think is, that's my new theory about what might be happening. So let's try that. We'll run. Yeah, it makes way more sense here. Maybe you should open the chat window in Edge. Yes, of course I should do that. Edge, doing that now. Oh my gosh. When I opened up Edge, it opened up the local host and then kind of killed it for a second. It opened up the one right here. Looks like I need to change my login for Edge. You need to make sure you're not a robot. Select all images with a storefront. Here, let me let you see what I'm looking at here so you can see this here. Exciting, isn't it? Well, I guess that's a storefront. That's a storefront. I don't know. Yeah, maybe there's people out in front. I don't think so. All right, it thinks I'm not a robot. Really? Seriously? All right, let's go get my token. Oh, jeez. We highly encourage you to enable backups. All right, here comes my token. I think I got, what, 10 seconds? Oh, 18 seconds. So here we go. Boom. And I had boom, I forgot to check the box that says, remember this computer for 30 days. All right. So, got my chat room, and it's in Edge. Greetings. And I just sent that from Edge. Okay. So, excellent, excellent, excellent. Now we don't have to worry about Chrome. I saw, while we were doing this, I saw somebody do like a test purple burst. Yeah, and those were, I think, 2 different ones of those came out. And then test orbit. And I think orbit's going to fail because we don't have that apply forces. Oh, no, wait. Orbit didn't fail. The wind. So here's what we're doing. We're calling apply force here, but we're not calling it here. And I think the reason is because force, when it's not moving, I think somehow we get to a problem when we get down to about here, is my theory. What's magnitude? Magnitude is okay. Relative velocity is okay. Why? I should have hit something else to see that. Let's do this. Let's send out the force. Like that, and we'll continue to run it. Throw it out to console log. Inspect. Console. Oh, we need to refresh so we can see the log out there. Okay, there's the not a numbers there. So what's going on here? Our normalize is failing. What's going on with normalize? Get ratio, oh, length, divide by 0. Okay. I'll try something like that. And is that our problem? Was that it? Oops, are we debugging? Let's run. Okay, and now let's do this. Let's call apply force there, the second time for the wind, which for some reason we felt we needed to do. Still working. Is refresh done? Yep, it's done. Okay. Now let's change our dragon game. Yeah, I'm nervous. I'm nervous because I'm not liking the fix. To grab build test particle. Do I have another call to this? Oh, it's wind. So we can just bring that up right now by typing in test wind and see if the wind works. There it is. It's just off screen a little bit. Yep, that's the one I remember it was that we made before. And we can do that again. So we can see it go all the way across from the corner. It's kind of behind the chat window, but there it is. Okay. Okay, so wind is working. So it wasn't liking those nada numbers coming in because of the zero velocity. That's what was happening there. Let's remove that console log call, and let's get back on track to building the rectangular shaped emitter. So I've just refreshed. We'll just run through a couple tests here. Purple burst. There's purple burst. There it is. Let's test purple. What was the other one? I forget the name of the other one. Let's go see what we've got here. It's in Dragon Game. Purple Magic, right? And looks like Will beat me to it, but we didn't see it. Whoops. There's Purple Magic right there. Okay, cool. And we can also, let me refresh the stream so that we can see, we don't need this anymore. We can just do it right over the stream. All right, cool. Fun. Fun. Okay, cool. And so now we want to go, I'm going to go back to test wind, like that, and shoot that across. Good. So I feel like I've kind of got a narrow margin which things can work and not work. It seems like the problem was due to the velocity being zero, so we're trying to get the proportions of it, we're getting the ratios, and we weren't checking this for a divide by zero. So in our normalized call. So that is fixed now. And I think, yeah, I guess our margins widened a little bit in terms of, I guess it's not as tight. I was thinking, oh, the code feels a little more brittle, but I think that's simply because my misunderstanding of the problem. Problem really had to do with the length coming back a divide by zero when the length was zero. Okay, next, let's go into our emitter and let's create a rectangular particle generator. Like that. So we're going to have a width and a height. And it'll be centered. So wherever this position that's passed in, we're going to center on that, is what we're going to do. So this is where we want to put our intelligent code here. So I want to say, I'm not going to do vector from, our offset is going to be new vector. And the vector is going to be random max width divided by 2. No. Width. No, let's do the, I guess this is the shortest amount of code to do this. Divided by width divided by 2. Oh, let's just create a half width. Because we're going to do this every time and we're doing this thousands of times, instead of doing the divide thousands of times, let's do it once here. Right, we're making this call thousands and thousands of times. Let's do the same here. Let's change this to height, like that. Whoops. That. Let's declare both of these. And I think I can make these read-only and assign them only in the constructor. And then we're going to come down in here. We're going to go grab half width and half height. So we're going to take so basically I'm talking about the offset from the center of the rectangle. That's what I'm talking about. But the initial velocity, I'm going to need to be a little smart about calculating, I think. So there's my x position, and that's going to give me somewhere offset from, so that's the offset. Oh God, why do I have a non-zero offset here for, oh, I wanted it to have at least something, so it was pushing a little bit off of something here. We'll play with that in a second, non-zero. So it wasn't right at zero because I wanted to give it some sort of velocity so it wasn't just sitting there. This changes to half height. And change this to height, like that. And so there's my new vector. I'm going to make both of these fit on screen. These parameters show up on screen so we can see them. It's a little easier to read. And now I think I want to do the non-zero offset. Well, actually, that's not, we're not guaranteeing that anymore, are we? I am going to instead believe that we're never going to go out, we're never going to hit zero. I'm going to say that's highly unlikely, and if we do, then we just do. We're going to deal with the consequences of that. That's my offset. Now, one of the things I'm doing for velocity is I'm taking the emitter's velocity, I'm adding on a velocity for the radial that was calculated by this offset multiplied by the particle initial velocity get value divided by the offset's length is what I was doing. So basically just saying that we're going to normalize essentially the offset to some value of 1, but basically take that direction that it's in and multiply it by the by that particle velocity. So that's in the same direction but equal to the particle velocity. With a rectangle, the problem with this though is that what I really want to multiply it by is not the, oh wait, could I do this? Oh, yeah, you know what? I think I can. I think this code is actually going to work. I thought I was going to have to change it, but I've talked myself out of that, and I believe I don't have to change it. So we're going to do that. And then I think we are done for that. So there's my rectangular particle generator. And if that code is all correct, then we should be able to go into Dragon Game, go find our test particle, build test particle here. And let's come in instead and say, set rect shape and pass in, say, what should our units be? Meters or pixels? I'm going to say pixels. So we're going to say 100 across and say 20 tall. Okay, let's declare this, drill into it. And I want to come down in here, and I want to have some code that's similar to what's in my setter for radius. Oh wait, should this be a vector instead? I'm so uncomfortable using the vector as a as the height and width. I think I need to change that to something else. I could make it another property, but should I create a class called size is the question. Not sure yet. We're going to stay with this for now since I'm in this direction right here. Why not just pass in a new particle generator? I don't want to do that. I want to make it simple in the client code. I can do that. The answer is we could do that. That was my first inclination. But what I really want to do is I want the client code to be have a lower burden on folks using this. So now what I want to do is I want to same kind of code here. If we're in this, then we're going to come in and we're going to say dot, shoot. Hold on, maybe I have a slight problem because I'm only calculating half height and half width here. Yeah, it's getting a little messy. But it's going to make client code easier. Okay, so let's just changing these around a little bit. Put that there. Like that. That was a duplicate line that intelligent or that saw that I was changing width to height before. So we're changing those for me. Why is half width? What's my problem here? Can I assign half width because it's a constant or read-only property? That's no longer read-only. Okay, we're changing that. And then we need this line of code essentially right here, but I'm going to use duplicate line to change it over. Got one of them, but not the second one. Like that. And it doesn't go there. Sorry, it goes here. Okay, so now when we set the width and height of this, we'll automatically set half height and half width, which should happen there. So now we can go back into, we were in here. And we're going to say particle generator dot height is equal to, oh, you know what I want to do? Let's do this. Let's go jump into, I want to make these private. Okay, so we don't see those in IntelliSense. So now I want to say height is equal to height, like that, and duplicate the line, and width is equal to width. Let's change the order of those. I like to work with that. Otherwise, we're going to say this is equal to a new particle generator. So what this does is this allows my my client code to more simply use these two default shapes without actually saying explicitly I want to be a circle or I want to be a square. If I set the property, the act of setting radius to a value will mean, okay, well, you're going to be a circle, and the act of calling set rect shape will be like, okay, you want to be a rectangle. And that's all I have to do. Radius is not in here anywhere, so we're good with that. So now build test particle, if we refresh, let's bring this back up. So wait, why isn't, oh, maybe because I'm starting with build smoke, I bet. Yeah, that's why. Okay, so comment that out, uncomment that, refresh. There's a rectangle. That's kind of cool. Let's turn off the wind for a second so we can actually see it working. Let's put it in the center of the screen. I'm going to comment out this line of code right here. Get it in the center. Screen center X, screen center Y. Give it no velocity at all. Turn off my wind. I can just comment these two lines of code out and refresh. Yeah. So, however, the distribution doesn't quite look even to me in terms of that. Well, actually, the rectangles, it's 100 across. Let's change the shape. Let's change the size of this thing. Let's make it 500, 400, 500 across, and 200 tall. Maybe 600 by 200. Or actually, let's do this. Let's do it 200 by 600. See what it looks like. Refresh. I'm thinking it's going to work the way I want it to work. Let's go back and change this just a little bit. I'm going to make this really thin. I'm going to make it 200 by 1. Yeah. So I think part of the thing is that I'm not quite happy about is that I'm shooting out if I'm on either side of the center, but I think arguably whatever my shortest dimension is, the distance between there and there, that's the piece that should say, well, whether I'm shooting out or not. And if I'm inside of that margin, that border, that I should not shoot out. Let me try, before I do that or head in that direction, let me make one more change though. I want to turn off my initial velocity, particle initial velocity, turn that to 0. And I'm going to turn particle wind back on, and I'm going to make the wind blow, I think, in the upward direction at about a -1. Let's see what happens here with a refresh. Yeah, cool. So this is kind of what I wanted when the scroll comes out. So let me go do that. I'll do the test scroll. Oh no, it's called test open command. Is going to bring the scroll out. You see 2 of them here because I had one of the views up. Stop the other one. So this is kind of the effect I want when the scroll comes out. So let's refine that for this right now. Let's move this over. So I'm not sure how wide that scroll is, but I'm going to guess it's about 300 and something. So let's make it about 180 as the X. And we'll keep the screen center Y. No, we'll go to about, it's about 800. Let's make it about 450 down. I think that's roughly about the center of it. Hold on. This is probably more like 400 across. And yeah, I still am thinking the 40 down is looking good. So we'll make that shape that. Let's just try that and refresh. Okay. Oh, the shape we need to be 400. I want to just do one quick test to make sure we're off of the center. When I refresh, this should double up right here. Sunny 2405 is following. Thanks, Sunny. Yep, that's doubled up. Good. And so this needs to be about 200, I think, to get right around in that area. Okay, let's do a test open again. Shouldn't X be 0? No, I'm measuring the particle emitter from the center of it. Because wherever it's moving, just like I did with radius, I want the shape to be, yeah, so Will Bennett says, with regard to that. That's why up here in my rectangle, where is it? Whoops, over here. In my rectangle generator, I was subtracting the half width and the half height when I was figuring that out. So I got a number between minus the half width and the positive. So somewhere out on that line is essentially what I'm doing there. Okay, cool. So next, let's do a test open. Okay, so its width is kind of maybe a little too long, but it's not too bad. I want this to look like gold as well, so I want to fix that. So let's go over to Dragon Game, and let's change, let's do this. Let's say, scroll length. Like that, that's going to be equal to, say, 400. Then we will use it, this divided by 2 here, and this here. And now we're going to come down here and change this to, like, say, 370. See how that works. The center point's not bad. It's pretty close. It's maybe a little too high. Let's drop it down to, like, say, 460. That's good. The other thing I want to do is I want to make it look gold, more like kind of magical gold coming out. So for that, we need to tighten up our variance, our variance that we've got right here. Let's make it like 15 and see what happens. Let's do a refresh here. Not really tight enough. We also want to drop our saturation down as well to, like, say, let's try lower the saturation. Too far. Not bad. Our variance is still way too high here. Oh, is it because we're drifting? Let's turn off drift a second. And let's try again. What has happened? How did we lose? How did everything go black? I think we got a bug in drift. Oh, because we have this at rock. Let's change rock away here as well. Refresh. Okay, there we go. Better. Better, better, better. So I want saturation up higher. Let's try 0.8. And I want to move this up a little higher too. Let's change it to 40. Getting closer. Let's take our brightness and drop our brightness down a little bit. Okay. Now let's give our brightness relative variance. Let's give it some variance here. Let's make it 30%, and let's bring it up to a 0.5 or maybe a 0.6. 0.5. Let's see what happens right there. And so that should give us a little bit of variance in brightness. Ooh, that's not bad. It's not bad. We're getting a little orangey here. Let's do our saturation. Let's do the same thing. We're going to say the target is 0.8, and we're going to say our relative variance is going to be a quarter of that, or 0.2. The same as like going up or down by 0.2. So I'm going to say relative variance is 0.25, and now let's do this. Ooh, looking good. Let's increase our wind. Too much. That's not bad. It's kind of getting colder. A gold kind of feel to it. I feel like I'm a little bit too much in the red in my hue. So I'm going to just bump this up to like 0.45 and go to absolute variance is 10. Try again. Too far. Let's go back to 40. Okay. Now I want to change particle size. I want to get the particle radius to have a greater variance here. So let's drop down to 2.5 here, and let's increase this to 0.8. See what we do. See what we've got here. It's not bad. I'm kind of looking for that brownish, brightish yellow here. So which means I think we need saturation up. Let's go to 0.9, 0.2. I think we're getting close. I think we're getting close to that. Okay. One more time. All right, not bad. That I could almost buy as kind of a magical thing. Let's drop our particle lifespan to maybe 1 second. So it comes off. I think I'm going to make that a little more than that. That's kind of what I'm seeing. So that's what I'm imagining right there. Sunny2405 is asking, can you please show the performance tab in Chrome Dev? You got it. You want me to record? I can do that. Usually I feel like there's something else that is in here in terms of showing what's in there. If we go over to here, Task Manager, there's Chrome right there. Right there. Edge, which only has one piece open. That's it right there. Is actually taking on more than Chrome in terms of what it's using. Memory. You want to look at memory? Not bad. So we're kind of hovering around this amount. Yeah, the reason for that is because the particles, when they die, are cleaned up. So we're just essentially recycling the particles. So it's not too bad. I expect this to kind of go up and down between 10 and 20 megabytes. So that's kind of what we're expecting. Yeah, Sunny2405 says, nice. It's not bad. And so the idea here is that this is going to show up under, if I do another command test open, that's going to show up under these and move with them. The moving with them is tricky. I don't have a solution to that today, but I think it's going to involve keyframes. I think what I want to do is, in addition to having, because we could also do forces, where we say it's got a gravitational force associated with it. But I really want, hold on. You know what? I think I want more brighter. I want to go back and look at this. So my target is 0.5 for the brightness. Let's bring that up a bit. Let's take it to 0.7 and see what that looks like. Yeah, I think that's going to be a little bit better. So it's definitely going to look magical as it opens up. Or alternatively, let's do this. Let's take it down to 6, but make the variance greater. See what that gives us. Getting a little too dark, but the lights I think are going to be good. Let's try that. Okay, and then let's increase our particles per second to maybe 600. Good. Yeah, I'm feeling like we are really close to a kind of a gold magic dust kind of effect as we unscroll that, as we open that up. The other thing is, as this moves, if we were to go in and give this gravity right now, let's say it's equal to 4, the particles that come out, we'll refresh it, they're going to stay kind of where they were before they die. So I'll refresh that one more time. What I mean by that is the particles that were let off from the scroll up here will kind of be right there and kind of move up. So that whole thing is going to work kind of, I think, as we're expecting it to. The only possible thing that I may not like so much is, well, I think maybe just the lifespan of the particles is a little too high now that we've actually got motion in here. So we might want to play around with that. But it's I think not bad. Okay, so next I think I want to do, so this is like, I'm going to keep going because, crazy. Performance tab, hit refresh. Performance tab, hit refresh. I think you want me to do this. Yeah, I'm not sure. We can do a recording of this, but then that's going to be like, we're going to drive into that. Okay, let's go to, one more thing I want to do is I want to see this on a black background here. Let's come over here and see it. Yeah, nice. I think it's going to be fine. Okay. So next, so I'm going to keep going. We're going to kind of take a break from the emitter for a second. We're going to go back to the scrolling system, or the system to bring the scrolls. And I'm going to show you some assets that I have out here. So here inside of Scroll, I have Open and Slam, which you've kind of seen. I think it means the memory checkbox on the Performance tab. Hold on, let's go back. I definitely want to, this one, Show Memory Timeline. But I think I still have to do a recording to do a profile of the performance on here. And so here I can do this. We'll go ahead and do that for a couple seconds. It's still falling, so there's still work to be done. And then here it is. Without knowing specifically what you want to go into, this is kind of a, there's kind of a lot here to explore, and so I'm not sure what you're looking for, Sunny 2405. Okay, let's go, where was I? I was showing the assets. So I've got Open and Slam. So basically what's going to happen is this is going to slam. This particular animation is full screen, so 1920 by 1080. This is when the scroll slams down. And for context for anybody who hasn't been with us in the last couple of days, this is for a live Dungeons and Dragons Twitch stream where the Dungeon Master indicates it's someone's turn using an app on their machine. So it'll be like, for example, my turn to play. When they click on my name or face or whatever, this will slam down, and then it will be replaced with this animation, which then opens it up and like this. And as we open, this is where we're going to want that particle emitter to follow it using probably keyframe animation, I anticipate. So we get those little, those pieces there. And then after it does that, then the other thing we want to do is we want to show the backs, which are going to be one of these two images here, or possibly others as we add them. So these are going to be in the background. So what I want to do now is I want to create a class called Scroll, which essentially manages all of this. It builds its own emitters. It's going to move the emitters over time. It's going to select which back, and it's going to draw the back as we open up as well. So we're going to have to basically do, figure some stuff out to make all this work. So this is in scroll.backs. So let's go ahead back into our dragon game. Here we go. Let's add a new sprites class in here, and we're going to call this scroll backs. And actually, hold on. Right now, I already had scroll rolls, which is drawing an update screen, and scroll slam, which is drawing as well if we do a slam. But what I really want to do is I want to have its own class here. So what I think I'm going to do is I'm going to cut these from here. Somewhere in my TypeScript folder, I have, in the Dragon H game, I have the scroll, which is empty. And let's go ahead and create a class here. I just use CodeRushed to give me a quick template for this. And we're going to call this the, I'm going to call this the character scroll, character stats scroll. And this is going to now, inside here, own these. Let's go get rid of those. Actually, let's do this. Let's grab that. Come over here. Give it its update screen. And we don't need a super call there. And actually this could, I think, extend. Does that make sense? I'm considering, Will Bennett, if you're still with us, I'm considering having this extend world object, is what I'm considering. And I think I'm going to do that. And we'll play with that, which means I don't, let's see, world object. This thing is not moving, so I'm not sure if it needs all of that. Render is what I need here. Okay. So we're going to say render. And we're going to grab and we're going to grab, I think world has a context in it. CTX. Will went with convention. Congratulations. And so there's our render. And then scroll back. So now we've got to initialize these. Let's go back over to Dragon Game. Go down, look for some okay, we've already got the draw there. Okay. Whoops. I deleted the wrong one. Look for red arrows. There we go. And so, let's see, load Dragon assets, load resources, initialize. Where's Dragon Game initialize? There it is, right here. Yeah, so let's create here. We're going to say character stats scroll. All right, character stats scroll is equal to new character stats scroll. And let's declare it. And that's in initialize. And then in load resources, I want to call character stats scroll dot load resources. Whoops. Like that. Let's put it after our call to super. Okay. Do we need to declare that? Okay. And we're going to grab this and this. Ooh. I don't need any of that in there now. And we're going to say load resources here. That's what we're going to do. X November 1, XNov1 is following. Thank you for the follow, XNov1. Glad to have you here with us. Okay. Let's grab our scroll backs. Let's bring those in. It's in scroll/backs. And the base file name is just back, I think. Yeah, it's back. We have 2 that we're expecting. So this is right here is the expected frame count. There are 2. The frame interval we don't care about. It doesn't matter because it's going to, I'm going to call it static. which it means it's not going to animate, if I'm remembering this correctly. Pad file index, do I need to do that? No, I do not need to pad the file index. That just adds a 0 if needed for multi-digit pieces. So there's the scroll back. So now I want to say scroll back.draw. Excuse me, and okay, and then we will need a. I think that's all we need to do. Let's see if that works. If that doing that alone is going to update the screen because we added that object. Did we add the object to the world? We're descending from it, but did we add it? I don't think we added it. Will, you might want to refresh my memory on this in terms of. Do we need to come in and say something like, hold on. Does the game have the world object in it? World dot add character. I bet we have to do this. Like that. And so if we do those things, let's see what a refresh does over here. I'm going to close this down. Refresh didn't look very good. Add character of undefined. World's not there yet. I think we'll fix this in one of his check-ins. As I recall, one of his pull requests. Let's go take a look at that. Maybe time to do the pull request. You can create world in the constructor, says Will. Let's take a look at this here. As I'm recalling, it was in the wind pull request. Is that right or no? I'm not recognizing these. Hold on, I thought there were like 7 of them. Local forces. I feel like it's among these here. Nope, nope. Oh, I think I was thinking about, was it this I was thinking about with regards to gravity? Oh no, here. Here's the fix right here. So this was inside game.ts. We've got a constructor right there. We're adding it there, and we took it out of the start. That's the change. So I'm just going to make that one change right now and see if that fixes it. I'm going to go into game.ts and look for that. There it is right there. And we're going to move it up into the constructor, which might have been exactly what Will meant when he said you can create world in the constructor. So let's do that, and let's do refresh over here. No errors. Okay, good. We have no other, we're seeing nothing else. Let's add the back to it. So we see one of those. The way, if you haven't been with us the whole time, we've created, everything you're seeing is we've created from scratch. It's an overlay bot with a game engine behind it. Some of the time we fly drones around on screen during this stream. Things like collision detection are built in. Everything's done live on the stream, or almost everything is done live on the stream. Sometimes, you know, I get the urge to work on it outside of the stream time, but I want to get to Dragon Game. And actually, no, I want to go into character scroll. And I want to, in here, I want to just go to scroll backs, and I want to add a new sprite here. So I just want to say add, and I'm going to add a new sprite proxy here. And so the sprites are basically a list of images. And when we call add like this, and we'll say starting frame index 0, it's going to add a sprite proxy. And then now it's going to be able to draw. And so it is essentially using the flyweight design pattern to essentially manage a lot of things efficiently using a set of images. So by doing this, I should see when we come in and render, if we see it, we'll know that our character stat scroll is working on screen. So let's do a refresh and see if we see something. Oh, why not? Set a breakpoint. Can I set a breakpoint here? I don't think I can set a breakpoint there. Let's do this instead. Let's just send out the word render to see if we're coming here. Let's do a refresh. Yep, we're getting there. Scroll backs add. I don't get it. Why aren't we drawing? Let's do this. All right. So what do we got? Okay. It's got two images. So it loaded the images. Why aren't we seeing it? Is the question I have. What do we got? Is it a seconds versus milliseconds thing? Is the question. It should not be because I said it was static. So when we go into draw, or actually, well, there's an update frame call that should be happening out here somewhere. I think there's world object has a function called update. I don't think this is it, but let's come in here and let's override update because we want to be able to advance animation anyway correctly. So, and all of these, I think, has got an advanced frame call. Yep, advanced frames. So passing in now. Is now in seconds in the update? I think it is, isn't it? Timescale is in milliseconds. I'm not remembering. I have to check it. We'll pass it out as a parameter. I don't think this is the problem. Let's do one other one though too. Since we've seen roles already, let's come in here and let's say, let's add one to roles as well. We should see it roll in the first time when we refresh. See if we get anything here. Nope. Let's make sure we're getting, let's comment this out. Let's do a, say we're in the update, just make sure we're getting our update call here. Should see it. Yep, we see it. Let's go pass out now. See what that is. It's in seconds. And let's pass out timescale. That's the distance between now and the last time. Okay, so advanced frames, I think, is expecting it in milliseconds. I think, well, no. Let's see here. Milliseconds passed, yes. It is expecting it in milliseconds. So what I need to do, I'm not sure if there's a world dot now milliseconds. Remembering that correctly? Nope, I'm not seeing that. So I'm just going to say now times 1,000. However, still not explaining why we're not seeing these pieces drawn. Oh, it's game dot now milliseconds. Let's play with that instead. This dot game. World dot game. No. How am I getting to game? I think I'm stuck with now times 1,000 for a little bit here till I figure that out. Scroll rules dot draw. Oh, we call advanced frames automatically inside of sprites. Huh. Okay. So we don't need that. But now we do need times 1,000 since they're expecting milliseconds, I think. Still, that shouldn't be a problem. Huh. That was it. That was it. Okay, looks like we're drawing our scroll on top of our scroll rollers. So we need to put the backs and draw them first. Refresh. I think it's going to look good once we get that in sync. Not bad. Refresh again. Okay. I need to... I've got a test open out here in Dragon Game. Let's go find that. Oh yeah, that's not going to work. So let's go in. Let's see, what is it? This dot character stat scroll dot slam. We're going to do that and this dot character scroll dot open. So let's declare these. Jump inside. Oops, that's not here. That one goes here. This one's going to be scroll slam, which we don't actually need to clear it. We do for open, but not for slam, because slam kills itself automatically, but the other one is going to stick around. This is just, all I'm doing is I'm just copying the code over so we can initiate that. But what I want to do is I want to mark the time. It's equal to I want to pass in Will, tell me what you think about this. See how much you hate that, and we'll maybe figure out a better way to solve this. But the idea is that when we open, I'm going to mark the time, so I know when the open is. And so then I'll check the time, and if the time is within that open frame, then I'm going to crop based on the cropping amount that needs to be there. So it's a little crazy intense what we're going to do here with regards to calculations and things like that. But basically my open, if it's running at 30 frames a second, which means I can basically check each of these pieces. I can basically divide the distance in time, right? Check it by the frame rate to see which frame we're on. And based on the frame, I can figure out how much to crop, just essentially by just creating a list of elements and index into that list based on that. So that's kind of the idea here. I have 23 frames is what I have. So our this is our frame rate for our scroll open. I'm going to turn this into a read-only kind of deal up here. Here we go, read-only. And private read only, and we're going to call this the frame rate, like that. Yeah, Will's unhappy. He's sad. He says you can either pass the game to the class constructor or pass now to open. Can I get now here? This dot game, do I have it? I don't have game here. Oh, it's just this. Now MS. Oh, there we go. And should I use seconds instead? Yeah, let's use seconds instead for this new code that we're writing. So now we're going to come in and say now, which is in seconds. Open start is equal to now. Will's going to get happy here soon. All right. So there's my time right there. Then so I've got to do a little bit of math here. So frame rate is here. Should have, okay, this dot frame rate, this dot frame rate, and this dot frame rate. So, okay. And then the open, here's where we want to add the scroll back piece if it does not already exist. And here's also where I think we want to say, hey, scrollback.sprites is equal to empty. So we're going to clear that out, add a new one to it. So there's our open right there. And we're going to open starting with the default view, which is, when I say the default view, what I mean is this one that's currently shown here, index 0. If we come back over here to look at the backs, we also have this one as another alternative view. So and by the way, when we switch from view to view, I'm going to have the scrolls close and then reopen again with magic. So it'll be like that when we change. So I think it'll be kind of cool effect. That's what we're going for here, is building a cool effect. So there's our open. We've got our open start, and now in our render here, we need to figure out how much time has passed. And so what we can do is this: we can say elapsed time, and that's going to be equal to now minus open start. That's going to be in seconds because everything is in seconds. And then we're going to say, oh, hold on. Our frame rate is in milliseconds though. Let's do that. And so one of the conventions we're starting now in this, we've started since since we did the last pull request from Will, is anything in milliseconds, we're specifically saying it, and any other time is explicitly understood to be seconds. So that's a new convention. So here's my elapsed time is now minus the open start. Then we want to say, actually this should be let. Then we're going to say frame index is equal to elapsed time divided by my frame rate in milliseconds, the whole thing by 1,000. To get it to seconds, like that, which means I multiply. Is that right? Elapsed time. Yeah. Yeah, I think that's right. I'm going to keep the code like that. So that's going to give me my frame index. So if we go back over here to scroll, here's open. So here's my here's the frame index there, and I'm going to start up PaintShop Pro, and we'll take a look at this. So we can get just the distances on each of these from the center point. And so, let's see, here's what I've got right here. So I've just dropped a guideline here down in this. Not sure what the fastest way is to measure all of these distances. Okay, and then what I want to do is I want to check to see if frame index is less than or equal to, it's less than 23. If it's less than 23, then our scroll backs, we're going to do a crop on it. I think I have a draw cropped, don't I? Where is drawing cropped? Is it crop? No. I know it's here somewhere in the code. Search for crop here. It's when we do the walls. When the walls come out, they are cropped. It's in base animation. Okay. All right, so there is our, let's go move this over to scroll so we can see this here. And so that's going to be base animation dot draw cropped by index. And it's going to give me my frame index on there. And is frame index in here? Yep, frame index is there too. So piece animation is type part. So let's just come in here and we're going to say let base and type part equal that, and then we're going to say base anim there, draw crop by index. From index is the third parameter, so we're going to say x and y. In this case it's 0, 0, I'm pretty sure. The frame index, we'll use the base anim's frame index, we'll use that. And then we got to figure these other parameters here, what we're going to do on this. So in the source image, SX and SX and SY, which you can see right here in the tooltip, those correspond to where in the source image we want to grab it from. And in that case, we just want the whole source image. So those are going to both be 0. So we're going to grab the upper left. The width, this is the width of the actual source image. And I think base anim has got that. I think it's got an image width. What is it? It's a sprite width something. No, is it inside of here? Sprite width. That's what I want right there. I'm just going to call this SW so it matches the picture. Whoops. Scroll back dot sprite width like that, and make this SH, and that's equal to sprite height. So we've got width and height, So right here, we're on SW, SH, and then we want the destination width and height as well, which are going to be this. Oh, this is where we're going to change it. So the width is going to be the same. The height is going to be a different thing. And oh no, we don't have a dy in here because in our previous cropping, oh, the dy is this, I think. Yes. This is our sx and xy. This is where we're going to actually be placing it here. So this is the thing we need to figure out. So let dy equal, and here's what we got to figure it out. I'm going to say 0 for now. And Will, I noticed you're happy over there in the you went from sad to happy in a short period of time. Okay, so there's the dy, and that dy is going to be passed in here. Okay, and then the dx is going to be 0. So so pass those in here. What are we doing? And then our dw and dh, our dw is going to be the same as our source width. And our height, getting that right? Why isn't that highlighted? I guess it's kind of off screen here. Let me scroll it up here a bit. There it is right there. I was expecting that dh to be bolded. There it is. Oh, wait. Oh, I gotcha. Okay. So this is going to be some different. This is going to be SH, which we're going to have to figure out. And we have to figure these two out. Nope. This is DH. Sorry. That's what this is. DH, which means this one is DH here. Good. Okay. So those are the two things we have to do. If the frame index is less than 23, then we're going to crop it. So let's do this as a test. Let's, just to see if this code is working. Let's set the height equal to maybe 80. And the y equal to, let's say, 100. And just to see if we see something cropped initially as the scroll comes out. So that's what we want to do. And that is in response to the open. I think we're going to need to send an open command to test it. Okay, so let's do a refresh. Nothing there. We see nothing there. Let's do a test open. Here it comes. Oh, got it. So did you see that? Let's do that again in case you missed that. It is squeezing it because I need to use my destination height as the part I take from the image. I need to grab it from the center of the image is what I need to do. So let's go back and look at that. And of course the picture helps us out as well. So for the source image, I do need to grab from inside of here. All right, let's look at this again. We'll get it. So the scroll height should be equal, I'm sorry, the source height should be equal to this, the destination height. So that's one of the pieces we need. the dy and the dx should be here and here, I think. Because the source and destination x, I think, need to be the same piece. Let's see if that is better. Do another test open. That's what we want. Okay. Will, I noticed you did a test purple burst. Did that work over the stream? I wasn't noticing it. It did work. Okay, good. Excellent. There it is. Yep. Cool. In fact, we see two because we've got the live stream is happening as well as this piece here. All right, so now we just got to figure out those numbers is what we've got to do. And I think the way I want to do this, my idea is I want to just create an array, a JavaScript array that already has the elements in. And my guess on the syntax is that I can do something like this. I can say, what's the array going to hold? Is it going to hold, I think it's just going to hold distances. A single distance from the center point is what it's going to hold. So we'll calculate that. So we'll call this, let's see. Sunny says, could you please open and close if and else with curly braces? That's more readable for us. I don't have a problem with that. So there's one there. And I think that was just the one on this screen. We can work on that elsewhere. I kind of like them if they just have one statement each to be without, but I'm also okay with. Not a big deal. Okay. 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 So back up here. I think it's like scroll, open, offsets. And I may have to look up some syntax here, JavaScript or TypeScript syntax. But I'm guessing it's something like this is what it looks like. And then I can just simply list the numbers here, 1, 2, 3, like that. Let's see if we get any red squiggly underlines. Doesn't look like we are. So now we can come in here. So let's create these. Let's figure these out. This is some manual labor. But our first one is going to be 0. Actually, no, it's not. It's not going to be 0 because I want to go to the, I want to come up to here. What's the best way to do this? I grab this and I go from here to here. In the bottom right, I have the height of this as 47. So it's those numbers right down there in the status. The drawing up tells me it's about 47. So for the very beginning, we're at 47. So we're going to come in here and say 47. Like, where's my 7? There it is. Okay. The second one should be open as well. Nope. Second one is going to be, we're just going to go to that middle point, and it is, whoops. And it just needs to be a rough estimate of it. Not much has moved. It's about 48. And you know what I'm going to realize I can do a little easier is I can drag from middle to middle and just divide by 2. This one is about 150, so about 75. For the next one, that's the next frame. And here comes number 3. And we're at 211, 212, so about 106. Isn't this exciting, kids? Here comes frame 4. That's 286, so about 143. What's really interesting, so this is actually, I feel like you guys see me do this all the time on the show. It's like, let's make it perfect, right? Let's keep going till it looks perfect. And we're doing that right now, right? It's like, it doesn't matter what it takes. I want this to look perfect. So, okay, there's the 143 for that one. Let's open this one up. And this is index number 6, and we are at 429, so that's about 215. 215. Let's make sure we have 6 of these. Yeah, we do. We have 6 of those, so excellent. Our count's right. We haven't made any mistakes yet. Keep going. This one is at 487, so it's about 243. Here we go. Next one is at about 534, so about 267. If I'm doing that math right, I think I am. Okay, here comes 8. From there to there, and we're at about 584, which is going to be about 282. The least exciting part of the show, I think, is right about now, coming up here. From here to here, here we go. We're about 629, which is about 315. The distances are all increasing as we're expecting them. Here comes 10. And now we are at 667, so about 333. And we're kind of slowing down. Yes, I want to continue. I'm not a fan of some of the stuff in this app. Okay, here we go. We were at 693, so that is about 347. Wait, is that right? Yeah, 347. Okay. Wait, Will Bennett says 292 for this one. Did I get that wrong? I'll switch it to 292. That is the index. Let's double check it. It's 0, 1, 2, 3, 4, 5, 6, 7, 8. So that is number 8. Let's open that up. Double check it. Looks like it's already open, and we go from here to here, and we are at 589. So that's going to be 50 plus 40, 294 about. Yeah, 292. You're right. That's the one. Good job. Okay, I think we're on 11. Is that right? Did we get to 11 yet? I think we did 11 already. 12. Let's double check, make sure we have 0, 1, 2, 3, 4, 5, 6, 8, 9, 10. There's 11. I'm going to put this down on this next line. And so 12, which is this one, is 719, so about 360. I want to do this actually. The comment up here is 0 through 9. Okay, 10, 11, 12. Now we're on 13. And this is 733. So we're about 350, 365, 367. That's what I get. 367. Okay. 14. We're getting into small moves here. So we're about done with the math. Here we're at 761, which is going to be 380. It's kind of a bigger jump though from here to here to here. I'm not sure if I did a mistake in that last. I want to double check the last one, 13. 13 is 733, so it's 350 plus 15, 16, 17, which is going to be 367. That's what I had before, right? 367. Yep. Okay. We're going to keep it. Let's just double check these two, the distance jump. So between 11 and 12 is small. Yeah, there's a little bit of a bigger jump there between 11 and 12. So this is 10, 11, 12, 13, 14. 13, 14. Okay. I'm gonna trust that these numbers are good. I'm gonna keep going. Okay, so we are at 10, 11, 12, 13, 14, right? 10, 11, 12, 13, 14. Now we're at 15, which is here. Uh, 774. You know what I should have done is I should have just measured the distance and cut it in half. It's almost comical what I'm doing, because it would have been so much faster to just come in here. The mental effort is greater than I wanted it to be. So we're at any rate, we're at 385 is what I get for half of 771. 385, which I think is right for 15. 385, and now we're down to pretty small changes here. I think by the time we get to 16, 17, well, let's keep going. 16, from there to there is 791, so that's going to be 395. And yeah, there are lots of ways I could do this with less mental effort. And now here, we're going from here to here, which is 822, which is at 411. And this is going to be 415. And we're at 19. It's a little bit short here. I want to get from the same part in both. This is about... uh-oh. There's a measuring problem with the tool, as it's from the mouse, not from the actual spot. So I may have had a measuring problem earlier. That's not good. We can change the frame rate and test it. So we're at about close to 840 there, so it's about 420. And I am going to, so this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And then we're going to come down here and we're going to say, I'm just going to cheat a little bit and assume that our velocity is remaining about the same, about 5 or 4 each time. So 424, 428. And 432, so that's 20, 21, 22, and is that it? I think that's 22 is our last index. Okay, wow. All right, so that was some hard work that we had to do. So there's our scroll open offsets. So now with our frame index, then we want to say basically our offset is equal to our scroll open offsets of our frame index. Like that. And now, based on the offset, now we have to find the center point and kind of work backwards from that. The center point, let's close these down. No. No. I think it's going to be faster if I use the keyboard shortcuts. No, 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 no. Center point is right here. We're going to figure out that center point because it's from here that we want to crop and reveal. So here, copy, paste, and that is 437. Okay, so we're going to say scroll center Y is equal to 437. And there's our offset. So that now means our dy, which we have to figure out, is equal to our scroll center Y minus our offset. That's our dy. And our dh is equal to offset times 2. And I think that's it. And let's do a test open. Well, Bennett says, phew, I think I just watched paint dry. Yeah. Normally I'm not like this on the show. Totally fail. That totally failed. But it was really exciting to wait to see if it would fail or not. Let's throw out our offset every time here. So let's do console log, send out our offset, and let's see what we get. Like that. Let's refresh. Do a test open. Well, then it says cheaters never prosper. Offset undefined. What? The what? Really? Did I get the syntax wrong on this? Oh, hold on. Math.floor. Okay, it was coming up with an integer in there, and we want it to, I'm sorry, it was coming up with a real number. We want it to be an integer. Let's see if this is any better. Let's do a test open again. Let's try one more time because I had mine slightly off. Nice. You see that, kids? That's awesome. CodeRushed logo will not be there when the other game shows, but it's now looking like it's looking awesome.
Awesome!
Yeah, it looks real. It looks like I'm watching a. It looks like I'm watching like a video play or something along those lines. So cool, excellent, excellent, excellent. We need to still put the stats out here. We need to collect all the stats. I need to get the CodeRushed thing out of the way. I think I might be able to do that now. By the way, it's inside my game, my Dragon game. I think I got the in my update function. I'm updating my rocket. Update screen. That's the thing that's drawing the rocket. Let's just do this one more time. Rocket is gone. Now let's say test open. Yeah. Super cool. Super, super cool. All right. Should we try to get the particle piece running in there? I kind of feel like we should. Let's do that. We're going to create a particle generator for this, and we've already got the code to create that kind of gold-like piece over in Dragon Game. We were using that in our the build test particle right here. So let's do this. Let's take that code. We're going to come over to our scroll class. We are going to it's just occurring to me that there's not really an optimization there. I was thinking we might have an optimization there. Let's put this is the, call this build gold dust, like that. And let's declare this. Yeah, let's declare this. And call this top emitter. Whoops. We'll need 2 of these. Then I want to do this. I want to say let emitter equal this dot top emitter. Let's get rid of these. And let's do this. Okay, so there's our emitter. Let's do this as well. Let's say wind speed, like that. Set that equal to -3. And let's use wind speed here. And let's take this. Let's turn off gravity. We don't want gravity for this. And now let's do extract method, extract function on that. And we're going to say initialized magic dust, like that. And passing in the emitter, which is, now we can get rid of this. Scroll length, what? How did that get out here? What am I using scroll length for? Set rectangle shape. Yeah. Okay. Let's change this a little bit here. I'm going to call this get magic dust emitter. Get magic dust emitter. And I'm not going to pass that in. And instead, I'm going to create it. Okay, get magic dust emitter is there. And so now I'm going to say this dot top emitter equals the top one, negative, let's change this to a 3. And then no scroll length, not passing that in. And the scroll length, really that, let's check out what the scroll length is here. Scroll length is from here to here. which is 348, I mean. 348. 348 is what the scroll length is. Let's make this a const. Okay. All right, so I've got that. I've got my particle wind. So my top emitter is going to have is going to blow the particles down, and the bottom emitter is going to blow them up, blow the particles up. So the opposite of that. Let's declare that. Okay, so now I've got my emitters. My build gold dust is here. Let's put this. Let's build this in a decent place. I've got what, a load resources override. Or this may not be an override, actually. This is not, is it? That's just here when I'm loading the resources. Okay, so let's, I guess I can put it here. Let's go into world objects. Let's see if there's a better place to put this. What do we have? Yep, there's no real initialization. I can do it in the constructor. Let's just do it in the constructor. Okay, so there's my build gold dust call. And that builds the two pieces. Now we can come in here and we should be able to figure out where to put the emitters. And then we're going to call draw on these two guys here. What is it? Update? What are we calling? Update? Does update do the drawing? I think it does. Let's double check that. I'm forgetting what it is. There's my apply force, particle, super update. Nope, I got to add these, don't I? That's what you're about to tell me. Render? Oh, is it render? I think I got to add these, though, so that update is called. Because I have not added these in here. I think I need to come in and say this dot world. Where's world? Render gets it. Pass in world to the character stat scroll constructor. Like that. Then we're going to pass it in here. Build gold dust. Here it comes. And then we're going to say world.add character. Top emitter, and world add character. Don't need to pass in world in the constructor. Where is it though? I'm not seeing it. I didn't see a this dot world out there though. I think I do need it. I guess that's the part I'm not quite getting here. And I don't think I need to call. Need to override pre-update, update, and render so you can call the emitter. Wait, hold on. Don't add them to the world. Oh, emitter's local to this class. Sorry, I missed that part up there. Okay, so I'm not going to do it then. Fine. Fine, see if I care. Okay, so we're not adding world. We're not going to undo all of that. Back it up. Back it up. And back it up. Okay, there we go. So need to override pre-update, update, and render so you can call the emitter. Okay, so let's try that. So let's go into world object again. Look at those pieces for update, pre-update, and render. Okay, go back to scroll. There's my render override. So I've kind of already got my rendered override. And so what we're going to do here is we're going to come in here and we're going to say this dot top emitter dot pre-update, passing in now, time scale, and world. Feel good, Will? And then we're going to do that with bottom emitter as well. Got that second line of code quickly just by using duplicate line from CodeRushed there. Okay, so pre-update is there, done. Update is there. Don't need post-update, and I don't need render because we've already got render down here below. So update, we need to call update. This is passing the same three parameters. And then finally in render, we need to render these at the right places. We need to, okay, this, I'm not sure why that is there. What you got? Don't forget to call super. Oh yeah, thanks. Super, super, super. Let's do that in a second. This is going to be render. Passing in now timescale world. And we need to adjust the positions. I'm going to put a marker here so I can come back. We need to adjust that position to make sure it matches the right spot. And we need to change our emitter so that it kind of cleans up and goes away after all its particles. In other words, we need a kill switch on the emitter so it doesn't stick around. We'll add that in a second after we first test this to make sure the emitters are moving. Oh, it feels like there was something I needed to get to. Oh, super. That's what I need. I need my super calls. Super. And then super.update. Okay, and I've got those. What about render? I don't think render is going to make a difference for render because nothing's happening inside of there, but probably doesn't hurt. Okay, so let's do a call to render. A super call as well. All right, let's move the emitters. Let's get the positions right on the emitters. Okay, so if the frame index is less than this, then we're going to say this emitter dot position. Please let this not be read only. And we got a setter on it. Nice, just what I wanted. Okay, so that position is equal to new vector, and the x is always 0 on this. The y is going to be equal to dy, which is going to put it right behind the scroll. That's the top emitter. The bottom emitter's position is going to be scroll center plus offset. Holy cow, is this going to work? I can't wait to find out. Huh. Okay, so I think the answer is yes, it's going to work. We haven't actually done the test open yet. We don't have any state inside of the scroll yet. So we created our emitters. We actually saw 3. One that happens at the beginning because of the Dragon H, the Dragon game. Will Bennett says, I have an extra bottom emitter.render call. Let's take a look at that. Let's clean that up. Yep. Not sure how that happened. Looks like I copied a little bit too much. Let's go into our dragon game and instead of doing the build test particle, let's go with the orbital instead. And so now we'll refresh. And okay, so now we've got our two emitters, our gold emitters that are up, and our orbital is running as well. Let's do a test open and see what happens. See if the gold follows the scrolls. It kind of did. Oh, but it changed its width somehow. The position. Oh, I know why. I know why it did. It didn't change its width. It's just centering it. It moved its center over a bit. Because remember, when we've got that, when we're spread out, we need to offset it so that it's in the center. Is what we need to do. So let's go get that part fixed. Go to scroll. This position is going to be our scroll width. Is this our scroll width right here? I think it is. Let's get to here. Be sure we got one. Yeah, so there, copy that, paste it in, and image info. And this is 348 wide, so that's going to be 150 plus 24, 174. So scroll center X is going to be 174. Let's see what happens now when we run it. Refresh. And let's go do another test open. And yeah, it looks like it's working. So it's not bad. We need to stop the emitters, stop drawing them when we're done opening. And, but it's very cool. It's pretty cool. It's a cool effect, and I think it's close to what we want. I think what I'm going to do is I'm going to shut it down. Stop the show.
Closer!
Yeah, getting closer, says Will Bennett. Will Bennett, you want us to keep going? By the way, yesterday's stream, I think I left I forgot to hit stop streaming for a while, and I went off, took a break, came back to my machine, I was like, ugh, duh. So there's about 30 minutes of looking at Visual Studio, nothing happening. By the way, orbit, notice in the orbit in the center of the screen, how it's getting tighter and tighter. That's happening because of, my contention is that's happening because of wind resistance. It's slowing it down. Before that did not happen. If we were to come into that orbit, to prove that that's the case, let's go over into our dragon game. And in the orbital, when we build it, let's set the emitter's air mass, or air density, let's set the air density rather to 0. Okay, and if we refresh that, instead of drilling into the center, it should maintain its distance all the way across. You know better than ask me that. Maybe you just want your wife to mate. Guess what? Wife is not here right now. Okay, let's do another test open. While we're out here waiting, here comes the test open. Whoa, 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 that didn't look good. Our cropping is off. What happened? I didn't notice that before. Why is that? How did things go horribly wrong? This is pretty obvious, and I don't remember this ever happening before. Huh. let me try something. I want to make sure it's not related to any performance related issues. So I'm going to just comment out the orbital starting here. Refresh. What? Looks like I got a problem. Looks like I want to, oh, I think I know what the problem is. Hold on. These all build the emitter. So what's happening is emitter is not, where's my emitter? Being built. I guess we'll do this. Okay. Let's see what happens when we come in here, test open. That worked. It's performance related. Is that really the problem? Let's look closely. I think it's performance related. That when the processor is taxed with all those particles. By the way, I love that when we immediately jump the position, if we jump it and reset it, the particles kind of, you can still see the other ones still flowing. All right, let's do this. Let's get the particles to start and stop. We'll keep pushing through a little bit more. All right, let's go to scroll and let's move these here. We're only going to, wait, no. That's not going to work because then as soon as it, that kind of works, but as soon as it's open, they're gone. So if I just move those, I'll show you what I mean. There we won't see them. Let's do the, Will Bennett. One big performance problem is in vector. It's doing multiplies and a square tool for every vector. Need to change that to be lazy. Okay. Thanks for that suggestion. Let's do a test open again. Boom. And then yeah, we need those to fade away. So oh, wow. And then the other ones, because it's not rendering, the other ones are all out there. We need to kill all the particles. We need to do a couple things here. But what we need to do is we need the emitter to continue to render no matter what. But what I want to do is I need to add a new behavior to render, top emitter here. And I'm going to say kill, like this. And kill here. And then, or maybe a less threatening word would be stop. Stop emitting. So we're going to do those. We'll add some code there. And then we need to also, I think if frame index is 0, then we need to start. So by default, it's running, but if I call stop, it's going to set a variable that says no more. We're not creating any more particles. And if I call start, it's going to kind of do the same. Okay. Excuse me. Let's get to fine. I think I'm going to do it here. Start, stop. So we're going to say, I think it's going to look like this. This dot stopped equals true. And this dot stopped is equal to false. And let's declare this. So we're going to, by default, start running. And then we need to go to, I think, add particles, and it's just as simple as this. If this dot stopped, then we get out. Like that. See what that looks like. Okay, so there's that initial burst as we create them. Let's come in and I'm going to switch my view over to here. I'm going to say test open and watch it. What the what? That was horrible. Let's try it again. What's going on with that? How did I mess that up? Scroll. Primitive is 0, we call start. Otherwise we call stop on the emitter. Yeah, I don't get that. I don't understand how those changes are resulting in that behavior that we're seeing. Let me just comment both these lines out. Just verify that those changes in fact led to it. Okay, I'm stunned. What happened in there exactly? Start, stop. Let's go look at what we've got. Look at the code here. One more time. This dot stopped, this dot stopped. If this dot stopped to add particles. Is the problem last particle creation time? Is not being set? No. Particles created less than 0. Return. We get out before hitting that try finally. What? How is this possible that that line of code is causing this problem? One more time, double check, refresh. So do a test open. Try again, test open. Okay, that's normal. Uncomment the line of code. And refresh. Do another test open. As soon as we get loaded. That's some crazy insanity to me. I'm doing less work and it's crazy. Hold on. I'm calling stop multiple times in my update. So add particles is not adding any more particles. That means the particles have all got to be gone. Let's go into scroll. I just want to, at the risk of making things worse, I want to go in here and I just want to say it's stopped from the beginning. And let's just see what happens here the first time if we come in and refresh. So we should see no emission at all. Seems like it's taking longer to refresh the screen. Let's do a test open. It's a mess. It is absolutely a mess. Why would doing less work result in a performance problem that looks like it's, because it looks like we've got a performance problem is what it looks like we have. That makes just no sense to me. And nothing in the console window. Yeah, I'm pretty much at a loss to explain this. Okay, I think I got it. It works. It works. The problem is we don't have enough time because of the speed at which it's coming out, to add them. I think is problem one. I think problem two. So I'm trying to work out the performance compromise here. Let's try doing a couple things here. Let's look at scroll. Let's change our frame rate and change it to 10 times slower. Let's make it 10 times slower. Refresh. And see if it works. See what the difference is. So let's try it. Look at where add particles is called. I don't think that's the problem, Will. I think the problem is it was working before because we're creating particles and they were kind of already kind of out there. Does that make sense? Maybe that doesn't. Maybe I'm going to withdraw that hypothesis. So here we go. So I think part of what happens is the first call to add particles. Well, I don't know. Let's do this one more time. Let's make it even bigger. Let's take our frame rate and make it about 800 milliseconds for the frame rate. Let's refresh. And once it's loaded, we'll send the test open command. Here it is. Okay. We might want to interpolate is what we might want to do. I'm going to add some interpolation to this and see if that helps. I think part of the problem is we're moving the emitters by the same chunk of space, but we can actually get this much smoother. And so I'm going to try interpolation as my first attempt at this. So that means in order to interpolate, I was considering adding I'm going to add one more to the end here. So I'm going to add one more on there. And then, let's see, there's my offset. And the offset is that. But then I want to also do another number in here that's like I'm going to call it super precise offset. This is going to use my interpolation. And so this is going to be equal to, we need to find out where between the two the frame index is. So frame index that. Frame index is equal to the floor of that. And then now what I want to do is I need to find essentially the distance between 0 and 1, in other words, the decimal portion of that, of the frame index precise, and then multiply that by the distance between the two offsets to get where I should be in that range. So that's what I'm going to do. I'm going to say super precise offset is equal to, well, let's first find the frame index precise. Do I have a, oh, I can just do this. I can say frame index precise minus frame index, like that. That's going to give me the decimal portion. Let's do this. Let's create a new number for that. And this is going to be the decimal offset, I guess. Not coming up with a great name for that. So that's my decimal offset. Then I need another one that's going to be distance between offsets. That's going to be equal to this is frame index plus 1 minus decimal offset. No, wait, minus offset, sorry. Minus offset. And so that's going to be the distance between offsets. The decimal offset is there. So that's going to be a number between 0 and 9. And then I think all I need to do is super precise offset is equal to offset plus distance between offsets times decimal offset. And I'm not sure about this. I'm like, my brain is starting to be like, what? Spinning around a little bit. But if that's the case, then now the emitter position is now going to be scroll center Y minus super precise offset, or scroll center Y plus super precise offset. Let's see what we get if we do this. We refresh. We come over and do a test open. Nice variable name says, all right, here comes the test open. I can't tell if it's working because they're at the bottom. Let's move them to the top so we can see if it's working or not. Let's put our renders on top of the roll. Try again, do a refresh. Here it comes. What's happening there? Now it's working. Something was weird at the beginning. These are all good. The first ones are weird. These are all looking good though. And then they stop. So why? Let's look at this one more time. Refresh. Send another test home. I actually just realized I don't need to do it, but here we go. One more time. It's like it's going to the wrong place. It's like the top one is going to the bottom and the bottom is going to the top. Have I made a mistake here? I'm not seeing anything that I think would lead to that problem. Well, we're not setting the position. Let's do this. Let's let's set the positions here. Oh, shoot. That's not going to be happy. Okay, so let's go fix that. Fix these. Why am I not finding scroll? What's happening here? What did I do wrong about my declaration here? Oh, that's why. Oh, no, wait. Yeah, okay. Because it's not called scroll. That's why it's called scroll.center. Character stat scroll is what it's called. Okay. Then the super precise offset is going to be something else. It's well, I'll get this in a second. Let's go fix the other scrolls. They're up here. Okay, now what is my problem? Character stat scroll. What's going on here? What am I missing? Why can't you find center X? Missing static. That's my problem, I think. Okay, good. And now this right here, when we first start, that's going to be off by this first number right here. Scroll, open offsets of 0. And I think I want to make this static too. So I don't need one of these for each new piece that I create. All right, let's see what happens now when we refresh. Oh, you got it way before me as usual, Will. Thank you. All right, so let's do test open. Here it comes. Uncut read property 0 of undefined. What's that? Frame index. Okay. Wait. What's my problem here? Cannot read property 0 of undefined. Oh, it's scroll opens offset. Got it. It should not be this stat scroll opens offset. It should be character stat scroll of scroll opens offsets right there. Okay, one more time. Refresh. Here we go. Now, did not change. It's that weird thing that's happening at the beginning. It's like we get a burst of particles. Everything else is good. The very beginning, though, is not good. One more time. One more time. It's good. I needed to get a little bit further away. Again. Yeah, more. Oh, look, you can see the cropping of the. Oh, yeah. Interesting. Test open. Huh. Now it feels like it's working. What is going on? Why is it working now? So what's interesting is if we let it sit for a little bit, it's, I think, as if there are a whole bunch of particles that still exist. Is that true? There shouldn't be any when we do a start on this. Let's set a breakpoint and just kind of look at some of the values as we go through here when we get our start command for our open. Let's set a breakpoint there. And let's do a test open. Here it comes. So here's our breakpoint. I'm interested in this .top emitter. And let's see what we've got in here. I'm expecting to see no particles in here at all. Oh, last particle creation time. I bet it's something along those lines. Particles, it's an array of 0. So nothing inside of it. Length of 0, just like I'm expecting. But I bet last particle creation time. I think this might be the issue. Let's hope. Let's see if that has any impact at all. How are we using this? We're using this here for add particles. Oh yeah, that determines how many particles we need to create, I think. The add particles call figures out number of particles to create based on the last particle creation time. So what we're going to do is in our stopped is we're going to set that equal to undefined. That's what we're going to do. And I think that's going to fix that problem. Holy cow. Is that tricky to find? And of course, I'm assuming that fixes it. That better fix it. So there's that. Let's go back over here. We don't need this. And we're going to just run and refresh. Let's refresh and come back in with a test open. Here we go. Nice. That's how we want it to work. Now, it looks like we're a frame behind on the drawing of this. I don't quite understand that. Let's see if we can fix the, see what's going on with that. Why are we, why do I have this here? Did I copy that up from down below? I did. Okay. Let's figure out what's going on with the frame behind. Let's double check one more time just to watch it. Yep. It's frame behind. Okay, so let's look at that. And frame index. Am I really going to do this? Let's see what happens. If I do that though, then we get out to I'm not going to do that there. I'm going to do it off by 1. All right, let's just, I'm hating this code I'm about to do here, but let's just see if this visually does fix it. All right, so let's refresh. Do another test open. Here it comes. Yeah, that feels like it's totally fixed it. What's interesting though is we've lost the emitters. What's happened there? Definitely lost the emitters. I don't know what I did. Is that simply because of this change right here? Let's change it back and refresh. Here comes, yep, something. All right, so with regards to cropping, we are trying to figure out why that broke it. Okay, so I am sensing my brain saying time to eat, so I'm going to try to wrap this up quickly. But I want to wrap it up without it being a hack. So that's my challenge here, trying to get this correct without fudging it. So the DH is where I'm grabbing the offset. Yeah, so it seems like I need definitely the next offset. Oh, here. This is the problem. I think I do need to come in here. This is the fix, the correct fix. If I do it like this, so I'm still like, it's a little bit of an ugh, like gross. But if I do that, I think that's going to keep the, yes, exactly, Will. You got it again, man. You're so good. All right, here we go. No. Oh, that should have totally fixed it. Why didn't that work? Did I fail to refresh? Thought I refreshed. Did I not save? That really feels like it should work. Nope. Why did that not work? What is it about frame index being slightly bigger that's causing... Oh, we're never getting start called. That's the piece that's missing. All right. Okay. So let's refresh. Yeah, I'm not liking this. There we go. There's kind of a weird jump there. I think that we've got one of our numbers wrong. I think that's what it is. Let's double check that. Let's go change our frame rate to like 1200 milliseconds, and let's count and see which one is wrong. Here we go, refresh. Do test open. 0, 1, 2, 3, 4. I think 4 is wrong. Let's refresh. Refresh one more time so we can watch it. Here we go. 0, 1, 2, 3, 4. Yeah. Dare I do the same thing with the cropping? Yes, I dare do it. Let's, in fact, I wonder if, oh yeah. Let's change this back. Hold on, I'm gonna hit undo. Undo. Where's my next undo? Undo, and then undo. There we go. So that's where I'm going to. My contention is that just like I need, I'm using offset, I need to also use, I think, super precise offset. Because, you know, why not? That's what I think I need to do. And let's take out that. We don't need that anymore. Yeah. And now, let's see if that fixes it. I really hope it does. Here it comes. Oh, look at that, though. It's not bad. We can see it kind of moving up. But it is a bit behind. The emitters are looking pretty good with regards to their positioning, but the but it's like the numbers are wrong. Why? All I can think of are crappy ways to fix this. If the emitters are coming in the right position, why isn't the, hold on, I want to look at this one more time. Emitters are behind. Okay, we just repeated it and it's now working correctly. Hold on. One more time. There it is. Now it's not. There's that jump. It's like we're jumping ahead. Why is that? All right, let's go back and let's try one more thing. Let's take our scroll rolls, and draw that. Sorry, not that. It's like, oh. Yeah, I want to do the scroll rolls and draw them before. I'm just going to move these up here so we can see this just a little more clearly. Yeah, it is not quite perfect. It's not reliable. It's not reliably perfect, and I don't understand that. It's not bad, but it's just not perfect. I guess that's the problem I'm having. I'm also not understanding why we're not seeing the rolls drawn underneath. All right, let's try, let's kind of go back and reassemble this the way it's supposed to be here. Let's put our emitters underneath the rolls like that. Let's change our frame rate back to 33. So we've got a 30 frames per second frame rate. Let's refresh. Send out a test open. That's reasonable. Let's increase our particle count on that, because this thing's only up for a little bit here. Let's inside our scroll. Here we go. Particles per second. Let's go to 1200. And refresh. And do a test open. I think I want to do something else, but I'm not going to do it today. But when I'm done with that, they just kind of stop, and there's this line of particles going out that I don't like. I want it to still kind of put out some particles as it's dying, but I want the opacity of those particles to diminish. So it's a small little change I want to make at the end of this. But in general, it's not bad. I want to also change the particle size. I want to drop particle size on this down a little bit. Let's see here, particle radius. Let's drop it down. Let's drop it down a little bit. Refresh. And we'll bet it says it looks good. Here comes the test open. That's a little bit better. Just a little bit of magic there as we open up the scrolls. So it's kind of cool. Yeah, I want it to continue. I want it to reduce the lifespan of the particles as it gets closer to its death. That's what I want to do. I'll probably work on that Monday, but that's kind of where we are. But it does look pretty good, though. We've essentially kind of had this thing. I'm sorry, I'm just like let's bump this up to 2400 and see how we get here. Let's come over here. Do a refresh. I want a few more particles out here since we dropped the size. And here's the load, and here we go. It looked a little bit too not random enough. It's, I think, a frame rate problem that we're kind of getting into. Just kind of throwing little bursts out. It does look pretty gold-like, though, which I kind of like. Particle lifespan, let's drop particle lifespan down as well. Let's go to 0.7. Refresh. Yeah, it's kind of got that shimmery kind of effect that's happening there. I think this is going to work. If I get the kill of the particle system, the emitter, if I get that, so it kills slowly and just and does a little bit of a fade out, it still emits some particles, but they start to fade out. That I think is going to be the end of this effect. That this effect is going to look pretty good. I love that we're getting this essentially all with code, right? So we're basically have this mechanism that we're building to be able to open up a scroll. We'll be able to close it up soon, draw on side of it, switch, open and close the scrolls, get that sense of magic, which we're trying to get in the spirit of the Dungeons and Dragons game. So I'm feeling pretty good about that. I want to say thanks to decrease the particles per second until it reaches 0. All right. I was about to end the show. Let's do fine. Let's create a variable called stopping. And then we're going to say, we're going to do this. Update. Update's called now at a pretty regular interval, so we can now do something like this. If this dot stopping, then we're going to say hold on. Let's do this. Private. I actually want to make stopped private and stopping private. And I also want to come in here and I want to say like that, and we'll set it equal to 1. Okay, and this is what I'm going to drop down right here as we, in that update call. So then I'm going to say percent particles to create is equal to minus equals 0.1 or something. We'll tweak this number right here. It's probably going to be way too fast. We'll try something like that. And then when we do, we want to check to see if it's less than 0. Then we're going to say this dot stopped equals true, like this. And then I think we're going to return out of here. That's what I think we're going to do. Should we call super update before we get out? Maybe we should. Okay. And let's see. Percent particles to create is what we want to do here. It's less than or equal to that. Then we'll force it, make sure it's at 0, so it's at least got a decent number. Don't go negative. And then we want to come in here and say particles to create is equal to that times this percent particles to create. And so this will allow 20 updates at our frame rate, which is going to be about a second, I think. Is that right? Is that about 20 frames per second, 30 frames, 60 frames per second? So it's about a third of a second, I think. Let's see if that works. Did I do everything I needed to do? Okay, test open. What? Did we not even see any particles? Oh wait, there are some. Why are they ending so early? That seems absolutely bizarre to me. If stopping, it's like we're stopping way too soon. Oh, last particle time. Boom. That's the problem, I think. If stopping, then that is what we need to do right there. Let's see if that fixes it. All right, here comes the test open. Nope, doesn't look much different from before. Let's double check it. I'm going to do a refresh on it. Nope, does not look much different. Why is it stopping so soon? It starts at 100%. When we start, it goes to 100%. Huh. I feel like we should not see this happen until it gets to the very end. Let's just see if I change this to a smaller number. This feels absolutely wrong to me, but let's change it to a smaller number, do the refresh, just see what the difference is. Huh. That was actually it? And I want to do all right, pretty good. It looks like it's coming out from, let's see. It's not bad. I want to do one more thing now, which is with regards to if the stopping I want to decrease the opacity of the particles as we're dropping down is what I want to do. Calculate opacity. If this dot emitter dot stopping, let's do this. Let's create a new, a new variable called, for lack of a better word, you can see that I'm like ready to stop, take a break. Call it multiplier, set it equal to 1. And then we're going to come in here and say, if we are emitter.stopping, let's not make this, let's make it, can I see it if it's protected there? I don't think I can, so we're going to have to make that right there and there. Let's make those visible. Okay. If we're stopping, then multiplier is equal to this. Then, sorry, this dot emitter, Then we're going to take our multiplier times our multiplier there, and take this whole thing as well and multiply that by our multiplier. Okay. So if we're stopping, then we get a special multiplier that's going to gradually reduce opacity. So now, if we refresh that, get ready. Roy's going to be stunned. Why? Because I'm going so long. Here we go. Oh, yeah. Seems like we've been doing this for a while, doesn't it? What, about 4.5 hours? Are we really there? All right, here we go. Test open. That's better. But I want to see more of that magic, I think. It's not bad. That one. Huh. So, let's do this. Let's do one. I want to do one more test just to make sure that everything I'm seeing is good. And I'm going to change my frame rate. I want to look at this a little slower. I'll do it to 500. So we're going to get half a second frame rate. Every half second we will have a frame. Let's do another test. Yeah, now what is going on? Why is it stopped? Why are we stopping this soon? Because I was kind of getting that feeling before. Frame index is less than 23. Oh. So frame rate, MS? No. It's like we're calling stopped for some reason before we... I do not get it. I'm set a breakpoint here. Well, let's not set a breakpoint there. Let's set a breakpoint on open and then set a breakpoint there. Okay. So here comes the test open. Pause and debugger. There's our breakpoint there. Let's go to set our second breakpoint here. Is this going to be fruitless because the time is just going to advance? I think it's fruitless. This is not something we have to control time to see this, but it seems like we're stopping way too soon. Let's do this. Let's set our frame index and send it out to the log, to the console. Okay. What do we get over in console log? Oh, we got a not a number. Not a number. I think that's our problem. I think. I could be wrong. Let's clean up our not a number pieces, see what our problem is there. Get rid of that. This not open start. That's my problem. This not open start. Okay. Let's do something like that. Refresh. I feel like I'm fighting it. That's what I feel like. I feel like I'm fighting it. Now it's stopped. And yet, the frame indexes are still there, coming in here. Let's see what's going on. Let's put a console log here. See what's going on. See if we're actually calling stop. Here comes the open. Now it's stopped. What's going on? Got some bug here over in that multiplier is 1 there. If this emitter's stopping, should never get out here. Let's see what is going on here. Could it be, I don't know if this is it or not, but could it be here that we're not telling our emitters to start when we come in here? I'm wondering. Not entirely sure. Let's see what happens. Okay, let's send maybe breakpoint line 208 and emitter. I'm going to do that if this yields no new information. Here's the open. Yeah, it's like we're seeing no call to stop. Line 208 and emitter. What do we got in 208? Fine. Yeah, but we're like, let's do this. I think this may be our bug. So we never set stopping to false. I think that's our problem. That's our problem. We never set it to false. Okay, I think I would have found that a lot sooner had I had a little slightly more refreshed mind. Okay, so refresh over here. Try again. Test open. So now the particles are continuing, at least the top. I'm not, oh, the bottom ones are weird. It's like they're off. Set it to false in start. Good idea. We can do that too. I think it's a good idea to put it here as well. Okay, but now we seem to have a new problem, which is it didn't look so good. Was the problem, the way I would describe that. The bottom emitter and the scroll location seems like it's off. Yeah, the bottom emitter, let's go change the order in which these are drawn. I'm not exactly sure why that should be changing at all. Over here and scroll. Let's change the order of this so we can visually see this again better. So we're going to take our rolls and draw them underneath our emitters. So we can see the emitter lines on there. Okay, and we'll do test open again. The bottom one is, it looks like our calculation for the top one is kind of right, but the bottom one is kind of wrong. And I wonder if it's because of the offset thing that we did before. Let's go back and fix that offset change that we made. I think, did we make that or no? No, we restored it, didn't we? Okay. I think what I'm going to do, because I feel like I'm making my progress on this is slowing down a little bit, and lunch feels like a good option to do as well. I'm going to get some food, come back, attack this a little bit later, and we'll see if I can clean this up and find the problem center. Longest stream since you started. That is true. It is the longest stream. Yeah, it's like I'm off by about half a scroll in terms of its center position. I feel like I can almost fix that with the center Y, adjusting that a bit. Let's make it 420, and let's refresh, and let's see if this is any better. The end is awesome by making that change. The end is totally in sync and looks good. Got a little bit of gold up at the top too. And I'm also feeling that feeling I want to back away from, I want to back away from this for DH and DY, and I want to change this to just offset I want to play with that for a second. Need that magic sound now. Talking about the test, the sound effect for when it opens up. Okay. That kind of felt a lot better. Let's look at it one more time. All right, let's change the order and the frame rate and see if we are feeling better about this. Okay, so we need our rolls on top of the emitter. So we draw the emitters first. We do the rolls, change our frame rate back to 33 milliseconds per frame, and refresh. And send the test open command out. That was horrible. That one was good. That one was not so good. Wow. That one was not bad. And at the faster frame rate, let's go back down to and put in the that specific offset we were calculating before, which was right here. Let's play with that. It's kind of interesting. The top one seems to be above the scroll sometimes. It does, doesn't it? One more time. Here we go. Horrible. Absolutely horrible. Not bad. Not bad. Not bad. Not bad. Yeah, but it does seem like the top one is in front of the other piece. Also, when I started, there's just a little bit of particles. There are a few particles that seem to be remaining from the other piece. And I think that what we need to do, I have a feeling we're continuing to add particles to this thing because it's still alive and existing. Let's go to the emitter here. Well, if this not stopped, we're returning. So we should be creating no more particles. But let's go look at, I think what I want to do is I want to say, on the start, I want to say this dot particles equals, and I think it's, oh wait, yeah. Is that right? What is? Oh, it's an array of particles. Can I clear it just with that? I think I can. I think I can. Maybe I have to do this. Maybe that's the better way to do that. The semicolon at the end. That might get rid of that little bit of. So we do one, yeah, that looks like crap. But now at least we got rid of the extras that were coming in. Subsequent ones are kind of looking better, but there's definitely a strange synchronization problem. And that's really curious to me. I'm not sure why that is. We'll have to look at that closer and see what's going on. But it's in general not bad. Hold on. Oh, wait. I think there's something. Hold on. Let's go into scroll. We modified the the center. This is, I think, 37, 437. So let's make it 440 and center Y. And let's, yeah, this is the top emitter's position, center Y, the top emitter. Oh, I'm squirming already thinking about this, but there seems to be some adjustment. Right here between the emitter and the cropping of the piece that's there. So emitter adjustment is equal to, let's try this and kind of tweak our way to get there. Let's see if we can get it in a little cleaner. So we're going to drop those down a bit. Did I get that in the right direction? Not sure if I did. I just want to see if I can get this thing. That did not look right. So the scrolling is now looking correct behind the pieces. Looks like that's the wrong way for the emitters. Let's try it -20. And I think I'm going to have to take a closer look at all of this to figure out what's really wrong. But I just want to see if I can get the look at this right. Nope. Nope. We've got a synchronization problem with this, for sure. The emitters look good. One more idea, which is that our and the idea was to add a half right in here was kind of what I was thinking. I got some magic numbers coming in here. All right, let's see what we got. Like I'm determined to get this perfect, and just by tweaking it and seeing what happens. And let's try this. Nope. Not any better. All right. Well, I think what I got to do, let me undo some of those tweaks that I was making. Let's get rid of that. We had that offset emitter adjustment. Let's kill that as well. And so we get it to it should be working. And then we're going to just look at the code and figure out what's going on. So with that, I'm going to check in the code, and we will close down the show. And so we are like, what do we have here? We've got, okay, created the, hold on, let's close character stats scroll class. I want to, let's close this down. And I want to rename scroll to that. Then I want to go into index, make sure, whoops, not there. Index, make sure it got the rename, and put that there. So now I've got that correctly named. Okay, so let's come over here, and there we go. Class up. Okay, that, I'm going to discard that. We made that change. Fixed divide by 0 bug in vector. .ts. Added fade out. Particle fade out when stopping. Added custom shapes for emitter. And what else do we do here? Minor stuff, and I think that's it. There we go. All right, let's stage everything, commit it. Excellent. Okay, thanks everybody. We will see you next week. Thanks, Will Bennett, and thanks to everybody else out there watching the stream. We'll see you on Tuesday.